Right, good morning, everybody. I'm assuming you know the health and safety where toilets are and what happens in the event of a fire. But should be saying that anyway. So my name's David Watterston. I've been a land surveyor for over 50 years. And worked in various places around the world and over the UK. So I've got a fair amount of experience. And the idea today is for you guys to understand what a survey is all about, how it's made up, what the process is involved in it, where's the level datum, how do you add information to it that's useful for any designer, whether it be a landscape designer or you guys are going to be garden designers. If you're going to do, because I imagine a few of you are going to be doing surveys on your own, and what you need to know is how to go about that, how to go about resolving any errors or overcoming any errors. And then if you need to work out the sheet size, and then once you start your design, you need to understand about volumes, areas, bulking, and the whole lot. And I'll try and get through that as quick as I can, not as quick as I can, but enough detail. There is a whole bunch of handouts in your portal or Dropbox, and there's a list in there of all the procedures or all the processes that's involved to enable you to do a survey on your own, should that case around. And also, if you're working for a large company, or you're the video keeps switching off. If you're working for a large company, you may inherit surveys. And if you're going to do a basic design on that, you need to know, is it any good? So you need to start taking a few dimensions across it, eyeballing things in. I'll show you some pieces of equipment that you can use to help you, assist you in that. They're low cost. Because before you do anything, you need to make sure that survey is any good for you to work with. All right? But at the end of the day, hopefully, you'll get an idea of all this. The presentation this is on today will be available as a PDF, a PowerPoint, and then it's obviously getting recorded and will be put online probably by tomorrow. All right. So I was on the council and committee member of the TSA, which is the Survey Association. Now, it's a trade association. It's not like the RICS, the Royal Institute of Chartered Surveyors. But it is good for finding survey companies to do any work for you. And it vets these companies, whereas the RICS surveyors are generally house valuers. They don't have a great amount of land surveyors or engineering surveyors. But you can go to the Survey Association, and you can go to the Chartered Institute of Civil Engineering Surveyors if you've got a site that you want, obviously, somebody to give you a good survey. All right. Something about me. I've got interested in 5 grandchildren, and I've spent a lot of time renovating properties, my own property and my family's properties. And then I was involved in some music from a young age and still trying do stuff on that when I've got 5 minutes. So the objectives of doing a survey is you need to know what you're going to do it for. Is it just a preliminary, or is it a full detail, as this one would be? So in here, they've surveyed pathways, hedges, walls, grid of levels over it, outline of buildings, adjoining buildings, etc., etc. So when you're doing a survey, you need to manage the correct order in which to pick up details and think about the sheet size. And you could pace the site because obviously the smaller the scale, 1 to 20, 1 to 10 will give you lots of space where you can get right into the detail. And certainly if you're going to be doing lots of planting, it'll probably help you position your plants and all that. But if you're doing it for just a preliminary, you could go up to 1 to 100, 1 to 200, depending on the size, obviously. But you want it to be manageable. You don't want to try and get it on an A0 size sheet. I don't know if anybody's ever used one, but they're very unmanageable. And if it's windy like it is outside, you'll be taken away. It'll act like a sail. So the ideal size is either A3 or A1. And most surveys come in an A1 size sheet. All right. So one of the main things you need to do is assume when you're doing any garden design, you may be changing the guts of the garden, digging stuff out, putting stuff in. But you'll also maybe changing the boundaries, the fabric of the boundaries, either taking out an old hedge, putting in a fence, putting in new hedging, or whatever. But you must be aware of the legal boundaries. And I don't know if you ever come across anything like that, but in lots of land registry deeds, you'll get little T's on the edges that denote the ownership of that boundary. And they sometimes can have an H on it. So if it has a T on the other side, it looks like an H. All right. It's very critical that you find that information out if your client doesn't know, and he should know. He should know what boundaries he's got maintenance considerations for, and what he trims and what he owns. But you don't want to go out ripping out hedges and end up with a lawsuit or getting sued because somebody said you've taken out mine, and they will leave it right to the very end till you've done all your work. You take out the hedge, you plant a new one in, and they say, actually, that was my hedge you took out a few months ago. And I want you to give me lots of money. So be careful with it. So if you don't get a plan, if the deed plan doesn't have anything like that on it, it should be written in the written deeds that it'll say the northern boundary is your ownership and the western boundary is under your ownership. And you've got to maintain it and keep a boundary on it, a fence, a wire fence, or post and rail, or whatever it is. It should state in there what it was when it was created, when the land was created and divided up, and what you've got to maintain. But it is important. So try and look at the title deeds or the paper deeds to find out if there is any information on who owns what.
The keys you've got there, that you can move around on the inside and outside, that doesn't make a difference. Just the dark line.
Well, if the T, so this person owns this land, yeah, so they own that boundary, that boundary, that boundary, that boundary, and that boundary, right? So this property in the middle doesn't own any boundaries because that T is on the next door neighbours. All right. So he doesn't have to maintain anything. So the other people around him do. All right.
Sorry, what's the difference between the T and the H?
The H is if there was another, if it was a combined boundary or it was dual ownership. We'd have another T over there, and it looks like an H because the two of them were joined together. All right. But you will have, so there'll be cases where you've got a nice face, whatever it is, and that'll generally, the boundary will be owned by the neighbour. And the reason being that he always will put the good side to face you. All right. So if it's like that, where you can see the construction of the boundary, you know how it's made up, then you own the boundary. All right. And because you put the good side to your neighbour. Now, if you wanted to have it like that on this side, you could build another fence 100 meters, 100 mile, 200 mile away from it. All right. But obviously then later down the line, when surveyors come along, they might know which boundary is what. You know, if somebody changes the other one to a wire fence or something, he'll assume then, because he's got the battens, the construction of the fence facing him, that he owns that boundary. All right.
Is that just good best practice?
It's best practice. I mean, a lot of people probably don't know about it.
Yeah.
You know, there's an awful lot of people that just haven't a clue who owns what. And my daughters as well. So you need to find out about it, because if you're going to do any changes to it, it could become very critical. All right. And rights of light. I don't know if anybody's come off right of lights. This is exactly the same. You cannot build anything. A nice gazebo, plant mature trees, have a line of cypresses or whatever your client wants that cuts out the light from your neighbour. All right. They're obliged to have, they've got a right of, I used to think it was from the nearest reveal, but it's not. It's from the centre of the window or door. They're allowed 45 degrees of light either side.
Repeat that.
Sorry?
Yeah, from where? Hang on.
Well, it's like that's this person down here, right? This window here is allowed 45 degrees, so that extension would stop his light. That extension there would stop the light coming in at 45 degrees. All right. Yeah. So if you get any neighbours and you get a survey done, you want to make sure on the survey brief that you're asking for neighbours' information, the position of the windows and the heights of the head and the sill. All right. Because if you cut out any of their light, again, they'll probably wait until you finish. Sorry, you want to ask a question?
Yeah, if it's an extension, but if you plant there a tree that cuts the light,
Sorry, say that again?
if you plant there a tree
Yeah,
that finds the light,
yeah,
it's the same thing.
it's the same thing. Yeah, as long as if you stop any light going to your neighbours, it's an issue. All right, so if you plant a lovely big tree, they might like it and there might be no issue. But the next neighbour that comes along might say, hey, about that's destroying all my light. Right? Or reducing the light into the room. So a lot of people let boundary hedges, trees and everything, just they don't spend the money to trim them all back. So there is an issue on it. And as I said, it's 45 degrees from the centre of the window. You cannot build anything in it. And likewise, I think it's 25 degrees from the top as well. But obviously, if that's more to the case if somebody was building a block of flats at the end, and 25 degrees up from that block of flats would stop the light coming into his house. And then you can go to the planner and say, I don't want that built because it's going to reduce my light into my house. All right? Make sense? Yes? No? So what do we use? Well, we use theodolites basically, which give you an angle, horizontal angle, a vertical angle, and a distance. And in the old days, you used to have to fiddle about with it, use micrometers, use bubbles, split bubbles, and then tape out the distance, or use it with tacheometry or some other method. Nowadays, they're known as total stations, and they're fancy pieces of kit. They've got reflectorless lasers on them, and the Bluetooth connection or radio connection, and they can work down to a millimeter in distance and a second of arc, which is very, very precise. A lot of people use global positioning systems, and they also use this to give them the height datums. So in the old days, they used to use benchmarks. They would use GPS systems to give them a height above sea level. And some people will use GPS all the time. The difficulty with GPS is that it's using satellite information. And it needs quite a lot of satellites in it to triangulate itself to know its position. And they're generally quite low on the horizon. So all the satellites doing is sending out a frequency saying, here I am, here I am, here I am. So you pick one satellite from there, it's saying, here I am. You've got another one from over there saying, here I am. And one go over there from you, say, here I am. And it knows the frequency, it knows the positions, it knows where they are, elevation. And then it triangulates by mathematics where it is. But the Americans and probably the Russians and the Chinese and the Europeans will have errors built into it. So you can't use it to direct missiles and use it for warfare, although they use it. So what the GPS systems have is error correction algorithms to take the errors out, and then it'll talk to a radio contact to a network within the UK or whatever country you're working in and get your position down to 10 or 20 millimeters. When they first come out, late 80s, early 90s, I had was given a demonstration by some kit, and it was very impressive. And when us as a company see these surveys, we're going to buy them. I had surveyed a whole bunch of control points, and we used the GPS to come in and position these. And I was amazed that 3 or 4 of the stations were within a couple of mil. One of them was even 0. And I couldn't believe that you could get that accuracy. Because remember, I was using that instrument to get 1 second of arc and 1 millimeter in the distance. So as far as I was concerned, it was very accurate. But this GPS system got it down to a few millimeters. And it's basically talking to bits of metal junk in the sky. It was just unbelievable. So some people get led into a false sense of security with them and go and survey your site. But depending on the weather conditions, that signal that's coming through can get disrupted a little bit. They know about the errors that have been built in, that they obviously don't tell them the errors, they try and get rid of them all. So they will go and survey lots of stuff that they think's good, and it's producing an X, Y, and a Z immediately when it gets to position. Whereas with surveying with theodolites, you take that reference to a point, you take the VA, and you take the distance, and then you can position that point relative to here. So if anything has changed over that, or you need to reproduce it and reprocess it, you can verify if there's anything getting in your way or anything that's affecting the accuracy. With the GPS system, it's a one-hit wonder. So you put the GPS down, press fix, it fixes it. And as I said, it's a position X, Y, and Z. Or it'll take navigation coordinates, easterns and northerns in degrees, minutes, and seconds. The thing is with that once somebody goes and GPSes anything, if they go back in there 4 or 5 hours later and do the same job again, there will be differences. And the differences can be anything. It can be 100 mil, 200 mil, 500 mil. So you need to be aware of what you're doing with it, because it can give wrong information. I had a huge survey we were involved in Bracknell, 300 acres, and we were surveying the roads, the boundaries, different levels, all the major trees. And then the client who we were working for came to me and said, we're putting all these drainage runs in, foul water, surface water drainage, and it's all over the place. It's running uphill, running downhill. It's not correct. It's running flat. And when the houses are all built and the roads are all built, if you've got drainage that doesn't work, it can be a complete disaster. And so I said to him, what's going on, John? What's the problem? He says, well, when they tendered for the job, they stated they were going to do it with GPS. So they did it with GPS. But as I said to you, the GPS is dependent on these satellites. So what was happening was the GPS position wasn't great, which doesn't really matter for a manhole cover before you put the pipes in, but it does on the heights. And what these were is on some, because surface water drainage is slacker than foul drainage, because foul drainage needs to be designed correctly to take the water and other materials away and not get anything left behind. With stormwater or surface water drainage, it doesn't really matter because it's just water. You know, there might be leaves, there might be other stuff, so that can go out over time. So what was happening was this end, one end of it was 25 millimeters, 50 millimeters lower than the design, and the other end was 25, 50 millimeters, 100 millimeters going the other way. So what you were getting was runs going all the way. So they started excavating, building these drainage runs relative to the engineer's information that had done through GPS. And it was pants, or as Andrew Wilson would say, shite. So they just, and he came to me and says, what am I doing? He says, how can I go over it? I says, well, you should insist, John, when you give out the tenders, you need to say it's fine to use GPS, but you need to confirm that information by conventional means, either by a level or by a theodolite or by something, or go and visit it 2 or 3 times. Because if you visit the same point 2 or 3 times, you can mean out the information. And if it's too far spreading, then you need to think, well, something's going on here and investigate it. But if you just take one shot and accepting it and go to the next shot, accepting it, you're leaving yourself open. So he had to rewrite all these tender documents to put something in that they used other methods or other information to prove what they were setting out. And obviously from the contractor's point of view, it becomes much more expensive. But from the client's point of view, he's getting something that he can depend on. And I've done a lot of surveys where it's sort of beautiful houses, lovely roads, and you walk down and you think it stinks here. And the reason it stinks is because the drainage has been put in wrong and it's all backing up and they can't do anything about it. So what they've got to do is dig up the whole road, dig it up to people's houses, or certainly to the boundaries, and redo the whole lot. And that may not work because the thing might have been designed that it's all down through gravity. So the other end of it, it just off meant to flow down, but it doesn't, it's flat, right? So they end up building it up so that it flows, but then that's below where it's now going to go out because there was errors further down the line. So what happens is they can't do it by gravity anymore. They've got to put in a pumping station. So they put in a big massive hole in the ground, a collection unit, that takes all the sewage, and then when it gets up to a level, it pumps it back out to where it was meant to go with gravity. And you can imagine it's a huge expense. So leveling, which we'll show you in the new year, is quite an easy thing to do. But it's one of the things that people always leave to the last minute. And it's the thing that can cause real problems, either on drainage, on retaining walls, on anything really. So, you know, if you're designing a sunken garden with a water feature in it, and you do your design, you get your survey, you base your design on the survey, contractor come in, digs it away, and then you find out that it doesn't work, it's too high or it's too low. And if you're digging out material, it's very hard to put material back in the virgin because you would need to compact it down and then leave it for a period. You can obviously, it's easier to dig out stuff if it's too high, but if it's too low, you're stuffed. So anyway, that was a long spiel on just on GPS. So survey information is quite important. A lot of people use laser scanners. So again, like GPS, they might come in, GPS a few stations, get the datum, set up a laser scanner, and that laser scanner will walk around taking either 1 million points or 2 million points a second, all right? So that is collecting a huge amount of detail, but it's only going to collect what it can see. So the laser scanner would get that base of this podium, but it wouldn't get the stuff that's hidden behind it in the shadow. So they would need to have another 1 or 2 setups to get it all. So scanning is great, produces huge files. And again, I scanned Cambridge Cottage. So I surveyed it with conventional means. And then while I was doing that, I surveyed it with a scanner. And when I set the thing up, the students just wouldn't leave me alone because they want to know, what does this do? What does that do? So it was quite difficult for me, whereas I had thought I could give them little areas that they go and survey and check it. So I banged in a couple of pegs, set up my instrument, and they were all, what's that? So I had to stay at night to scan it all. And then because it's this time of the year, the light disappeared, and then the scanner, to position itself, needs to look at data so it can do a rectification on the data to find out what it is. And because the sun was low when I was doing Cambridge Cottage and I was working this way, it just blew me out. So I had to redo quite a lot of the information the next day. So it's quite hard, but on your portal, there is something that says scan to go. And if you go on that, whether you got a Mac or whether you got a PC, you can go in and you can see what I scanned on Cambridge Cottage. And it's useful, if nothing else in the background, that when you go out designing, whether for a company, whether for yourself, and somebody then comes up, I'm going to use a scanner. You can then think, right, scanner, that's going to be great because it gives me a snapshot of everything. But it's going to be huge data. But I am going to be able to take dimensions out of it and look at it all and move it about, and it'll be great. But it's a snapshot of what's happening at that particular moment in time. And you might get scan data that isn't as good as what they say it is, all right? And again, what I did with my scan data is, you know, this kit's £80,000 plus your software, nearly 100K. So it's expensive. So what a company would do, we go out and scan it. They wouldn't bother trying to check it all. They'd assume the scan, because it links all together, is fine. They would never check it with conventional means. They might do a few random checks, but they won't go to the same extent that I would go. So what I did was I surveyed it all, and then I took that scan data, drew the lines around it, and then plonked that on top of my survey and verified how good the survey was and how good the scan fitted. So it's a useful exercise if you've got a bit of time, but knowing you guys, you're probably so busy it's untrue. But yeah, so I scanned Cambridge Cottage with a scanner. Million points a second, ending up with huge files, but it worked out all right. A lot of people use drones as well, and they use LiDAR on drones. And we had somebody who had a phone, and when we were at Cambridge Cottage, just chatting about how we go about things and accuracies and how you measure and how you check it. And this guy came up and I said, look, there's somebody away taking photographs of all the site, and that's what you should do. When you go to a site, give it a good recce, take loads of photographs so you know what's going on. And he come back and I said, you're taking all the photographs so you can base your design on it. He said, no, I was scanning it. I said, what? And he had a LiDAR on his phone, I think he had a 16 or 17. And he showed me it, and it had the scan of what he walked around with. And I was amazed. I thought, blimey, put me out of job. So I said, how good is it? And obviously, to do it on a commercial basis, you would probably need to pay for the software to get it. But anyway, on his phone, we had one of the windows in the bay window at Cambridge Cottage, and he took out 1.61 meters for the width from reveal to reveal. So I got out my Distone, took it, which is a laser-based thing, and measured it, and it was within 1 or 2 mils. And then we says, all right, we need to check. I was quite excited. I said, we need to check some other bits. And then my batteries died, so I had to tape it normally. But it was very, very good. Whether you could accommodate that into your day-to-day work, I don't know. Certainly if you're doing preliminary work, you could certainly go around with your phone and scan it all. And if you can bump that down into your PCs or whatever, and try and get a top image of that, it would give you a good starting point for doing any preliminary design. But for the leveling point of view, as we're talking about with the manholes and the drainage, you've got a conventional level that people will go out and use, and probably a couple £100, £250 for the level and the instrument and the tripod. And as I said, in the new year, when I go out and show you about levels, it's quite clever kit and quite not too expensive. And once I show you how to use it, it's a bit like riding a bike. you might forget, but then once you get your bike and jump on it, you're away. And it's the same with leveling. But it's a useful thing to have, certainly if you're going to be doing surveys on your own, or you're working in a large company that's quite critical that the information you get is going to be useful for your design. I would suggest you buy one of them or get the company to buy one so you can use it. So if you think things are wrong, you can check it, or you can add extra levels to do your design. It's just it's is that somebody talking? Hello? Wait a minute.
I think it was just Gabby microphone that it's not mute. Sorry.
Say again?
No, it's good. It's good. It was an unmute audio.
Okay. I think it's a useful piece of kit to be able to know how to use it. And when you got the opportunity to use it, then use it. And then you get digital ones, which use a bar code. So this is like when you go shopping, you get your barcode to scan it. These digital level use exactly the same. So it's not like what we know as a knee staff, which is like that one. That's called a knee staff. And it's 0.5 centimeter blocks. The Americans do, I think it's 5 millimeter ones. Again, there's a photograph in your handouts. And it's fine when you're close up, but when you're far away, 30, 50, 40 meters away, it's very hard to determine what it is you're reading. So the E-staff is much easier and much more useful. But with the automatic level, it's a barcoded staff. So you can never say whether it's right, because it's just a whole bunch of bloody lines. And a lot of people don't use leveling anymore because they've got drones, they've got GPS, they've got scanners, so they never use it. And they need to know what they're doing, because if there's no way that they're going to check the levels by anything else or have some verification, they're going to end up making mistakes. And this is where it's even more critical for you guys to understand what it's all about. So if you get a survey from something, you can look at it certainly from the context of where everything is relative to each other. But more importantly, is the levels any good? All right, because if the levels are no good, your design's going to be rubbish, because you're basing all your excavation, your planting, your raised areas and whatever, all on that survey information. Because you're saying from there, I need to go up 1 meter. And if it's wrong, then you'll need to go up 0.5 meter or go into the ground 1.5 meters, you've got a problem. So you need, the leveling is quite important. So the principles of surveying is, you need to obviously think about health and safety. Because in the old days, it was, you just took the risk upon yourself and you got on with it. So there was never anything about wearing a hard hat or wearing steel toe cap shoes or steel insoles. You just did your job and you were sensible. But obviously accidents happen. And as accidents happen, more and more things are bringing health and safety. So the health and safety considerations now are more about other people than they are for the individual. So you've got to look at trip hazards. You've got to look at if somebody throws a brick out the top of a building and hits you in the head, the hard hat may have saved you a little bit anyway. And even at that, you've got to look at hard hats because the sunlight destroys the plastic and makes it brittle. So think about that. You should always work from the outside to the inside, or from the whole to the part. And the reason being for that is that if you survey the bits that you want in the middle, and then you think, all right, I need to survey the boundaries now because we need to know the amount of paving slabs, the amount of fence panels, or whatever it is you're going to do. So you start in the middle, you're measuring around things, and then you start to measure out the way. Any errors that you've got in the middle get transferred out. So you should always survey the outsides and work your way in, because you're minimizing your any errors from your typing or your estimating. And you're going to try and minimize that. You need to be consistent at what you're doing. So obviously, once you get methods set up, keep them going. Economy of accuracy means that you don't spend ages trying to fix the center of a big tree. That's going to be part of the design. You're never going to get rid of it. And as long as you keep a decent distance away from it for the tree roots and the ground around it, then if you get it within 50 mil, 100 mil, it's probably fine. There's no sense in trying to measure lots of dimensions to it to try and get it millimeter perfect. You're better off that to drainage, to the boundaries, to the building, the things that matter. So that's your economy of accuracy. Safeguard all information. I've had people putting a booking board on top of a car and then driving away. And they go to site next day and say, oh, where's my booking board? And they can't continue with the survey or the setting out because they've lost all the information. And we were doing a big job in Ascot Racecourse where they were putting new escalators in it, and we were doing the footways between the two parts of the concourse at first and second level. And I was going to take over because this guy was going on another job. And I said, where's the survey information? Because I need to know what you've named your survey stations, what the levels of the survey stations, what were your ROs, etc., etc. We couldn't find it. And I said, well, I'll go to site anyway, and you might have left it on site. And on the way there, on a corner, I saw these bits of paper all at the side of the road. And that was his booking sheet. That was everything off his booking sheet, which he'd come round the corner of his car, it had flown off. Come bit, wind had caught it, few car tyres over the top of it, and it all gone underneath this hedge. And I managed, would you believe, to find them all and use them, and it was fine. I continued with the job, no problem. But it could have been that it was wet, it could have been that they were eaten by something, it could have been anything, but we actually found them. And there was probably about 10 or 15 sheets of paper that had a lot of very useful information on it that was not repeated, because when you go and measure something on a construction site, set something out, and then you go home, the next morning at 6 o'clock, 7 o'clock, they'll be in there tarmacking or putting down paving. So the original information that you got is non-existent. And you can't then measure from that to anywhere else because it's history, you've lost it all. So we need to know that source and that source data. And I did find it, but it could have been a disaster. And I've had quite a lot of surveyors that will lay down stuff when they're surveying. So they put that over there, do stuff over here. Then think, oh, man, that's the time I need to go home because I'm playing football. Jump in the car and leave it. And the thing is that if you lose it all, certainly in the old days, you had to redo it all because you haven't got it. So at least nowadays it's all recorded in instruments, but again, we've had lots of theft on instruments. And that's part of safeguarding. So I had one guy who was down in Cardiff in Wales, and then he went on to somewhere else, So he had 3 or 4 jobs of information on his total station on a little data card. Went to London to start this next job, hadn't come back to the office, got his instruments stolen, and all the data on the card, the whole lot was gone. So we had to redo it. And there's nothing worse than going back to resurvey everything that you've done. Because he was out for the best part of a week and he was really depressed. And I don't blame him. But he wasn't, it happens. It just happens. Or you get a corrupted data card. So you need to make sure that you look after your information and get it down, record it, number it up, date it, put where it is you are, what site it refers to, and just try and be as tidy as you can with it all, because it could come back and bite in the bum. Independent checks and verification. Well, you would do that if you did a survey anyway, but you'd also do it if you're going to inherit a survey, because you want to make sure, as I said, that survey is good for you to use for any design. So you will line up the corner of a building with a tree with a point on the fence, and you can eyeball that correctly, and then you can go to the fence and measure to something else, or measure from the tree to something else, and find out, is the survey good? When you put a straight line over the survey plan, you can make sure it's good. Honesty in data collection refers again to the old days, but it doesn't really change even modern days. People would fiddle the level closures So when you're leveling, you're meant to go start in one point, work your way around the site, come back to another point, and you add up the back sites and the foresights to get closure. And if that closure is more than 5 mil, 10 mil, then it means one of your levels is wrong by that much. And what you normally do then is average that difference through the amount of change points you have. So you get it down to 1 or 2 mil or nothing. But I've had surveyors who ended up 30, 40, 50, 60 mil error and would fiddle the last backside to make sure that it closes. The thing is that you don't know where he dropped it. If you dropped it in the last shot, fine. But if you dropped it in the first shot, that means everything that he's leveled is all 50, 60 millimeter out of position. So it was the honesty in data collection is paramount. And I can put my hand up and say I was coming back from a survey in Iraq, where we were leveling, doing airfield setting out for Saddam Hussein. I didn't meet him, but we were doing surveys for him. And we had to survey across the Euphrates River and the other river in Iraq. But anyway, we surveyed these things, and because we'd been booked on a flight to come home after 6 months, I was doing a whole bunch of leveling to prove our survey work. And I didn't have a chance, because it was loads of it, I didn't have a chance to reduce it all to make sure it closes. Because if it doesn't close, you need to redo it. And I honestly, hand on heart, was sitting in the plane coming home to UK, reducing my levels. And they all worked. But if they hadn't worked, how could I tell my boss? How could I tell the company? It's screwed. You would then need to look at it and say, well, what is the screw? We don't know where it's where you made the error. Is it going to be critical? Now, as it happened, the airfields were never built, and obviously quite a few years later, Saddam Hussein got bopped off. But the thing was that because my methods, my principles, the way that I went out things was honest, it worked out. So it's how you look through, write it down, add it all up, it was fine. But you need to have honesty, because again, you think it'll get hidden and it won't. So, and neatness and time frames. The neatness part is an individual. If you have neat and tidy writing, anything that you write down regarding any design, any surveys that you do should be generally good. If you're not very neat, then it can become quite messy. And I'm sort of midway between that. Being honest, is that I'll survey stuff. And if you look at any of the field sheets when we had COVID, again, I couldn't teach you guys. So I thought, well, how do I demonstrate what surveying is all about? So in the back of my garden, I surveyed it by taping. I surveyed it by chaining offset. I surveyed it by tachyometry, 3-stadia tachyometry, which is what you use the level with. And then I surveyed it with total station. And I think I might have done it with GPS, but I certainly did it with a rotating laser as well. And I compared all that information to see how good it was. And it was great. But if you look at my field notes in it, you just think, what the heck's going on there? It just looks like a mess. But because I knew what I was doing, I could understand it. But if I gave it to you to do, you think, so again, if you're surveying yourself, you're going to be drawing up your own work. But if you're working for a company, a large company, or for someone else, or you're helping someone else, then neatness is going to come into a big way, because they might take that information to draw it all up. And that's what I do when I work at the School of Horticulture, which I do in February next year for a week. We get about 15 students, and their task at the end of the week is to be able to draw up a professional looking plan, right? So when I've got them in a class like this, they just look blank. They just, what's the survey? They haven't a clue, because all they're interested is plants and seeds and diseases and all the rest of it. And it's a real challenge for me to get them to understand that and produce it. In the last 6 years I've done it, what they've produced at the end of the week is amazing. Not, they obviously, I finish at the end of the week, then they continue drawing it all up, and I think together about 4 or 6 weeks before the final drawings, and then I come in, take them away and compare them to what I've supplied. And I'm amazed. But the thing was, I banged into them that you're going to do a sketch of something. Now, if you're in a 2 or 3 man team, you do the sketch of something, every individual's got to do their drawings. So that information that you've collected needs to be given to someone else for them to draw that information up. So it needs to be A, good, B, neat and tidy, and accurate. And it was a real challenge because we do silly things, which you will do if they're not comfortable with surveying methods and skills. But you know, I had a lady, and she was quite old. So we were doing the leveling, and she was leveling all the points, and I was telling her how to mark up the sheet, put the level number on it, put it on your sheet, and then when you get to the office, you process it, and then you can add it to the drawing. And I said, you can use the staff back and forward, and you read the lowest reading, or you can use a level bubble and put the level bubble on the side of the staff. So I went over because she was going like this with the staff. And I said, what are you doing? She goes, I'm trying to get the bubble in the middle. I said, well, there's never going to go like that. You need to move it really slowly so you can find out where the bubble's going. And again, in the new year, you'll understand when we're leveling up the levels and we're using the staff to take the levels, that it needs to be vertical. But I just couldn't believe how she didn't understand the concept of if you've got a bubble and it's that side, you need to move whatever it is that way to move slowly, move the bubble. But she was really aggressive with it all and expecting the bubble, which is, you know, it's in a fluid with gravity, that it would stick there and she would be able to move it on. And it was crazy. So to get over that, and at the end of the day, she produced a lovely plan and the levels were great. So I was able to teach her how to go do it all. But it's just interesting how people, and then another student who had problems with, don't know, looking at lots of text or the colours or me talking or whatever. She spent a lot of time looking out the window. And I'd been informed that some of them have got learning difficulties, shall we say. So she was a lot of time looking out the window. I thought, I mean, what am I going to do with this? You know, I can't embarrass her by saying, can you please turn around and listen to what I'm showing you? And she didn't. And we went out, started doing the leveling, came back, and at the end of the day, where I thought she wasn't listening to anything, wasn't being attentive, she became one of the better students. So it was, everybody learns differently, everybody put things down, but if you can be neat and tidy and listen and try and find out what things are, and again, I've had people saying, with numbers, I'm no good with numbers, just give me a headache. And I'm thinking, well, the whole thing about surveys and numbers, really, whether it's a measuring a tape or taking a level. Because a little plant isn't with numbers, is it? It's just a little curly bit and it looks nice flowers. Anyway, she did really well. Right, so when you're out and you're wanting to get a survey, I don't know, what time do you normally break for lunch or break for a coffee and wee break? 11:15, that's what I thought, yeah. So you're working for a company, or you're working for yourself. The survey you've got is too big. You need to bring in professionals. Which way do you? Because you're going to get a whole range of prices. The company I used to run for 30 odd years, I've now finished with it totally. Our charge out rates for a day for surveying were about £850 a day. But that would involve getting to site, doing the work, coming back, processing, giving you digital data, modelling it, giving you contours, giving you hard copies, whatever you want. So one in price. Whereas some companies would charge you a field rate and then a guy right in the office to draw it all up. And then some companies will say, I'll do the survey for a couple of £300. You know, a third of ours, half of ours. But they will use either a drone, or they'll go in there with the GPS, a second-hand one, and only do it once. Or the drone will go over, take a load of photographs, make the maps, but it hasn't got any ground control. So it doesn't know the true distance from A to B. Because if they did that, they would know that the drone survey needs to come in, because the drone's using GPS for its fixes. It's basing it on the curvature of the earth, and there will be inherent problems with that. So with a professional survey, hopefully it'll give you all the data on all the information that you need, and they'll collect it all. As you said, I want my adjoining windows for the neighbours because I don't want any right of light issues. So I need to know where they are relative, so that when I do my plan, I can work out, is there anything going to get in the way that might stop them having light in their house. And you also want it to be the level accuracy, so that you don't dig more than you need to get out or whatever. And they won't assess who owns what in the legal boundaries, but they should survey the boundaries accurately. And then there's other things you can use to try and prove that. As I say, Google Maps is pretty good for giving me an overall thing, but if you go and get the Pro Map, to go and get the Ordnance Survey digital data, which is the whole country's mapped, and it is getting better and better and better. Whereas the old days used to be working at 2, 3, 4 feet accuracy at 1250 scale. It's now getting down to 50 or 100 mil. So it's actually quite good. So you can get a Google Maps, you get a Pro Map for about 20, 30, 40 quid, digital data. That, if you ask for the grid intervals, then when you put it on a CAD system, you can check that that grid interval is what the computer tells you, and you've scaled it correctly. Once you get that scaled correctly, then you can get Google Maps, put that on top of that, scale that up, and then you've got a visual and some line work that you can rely on. Then when you go to site with your client and you're discussing what you're going to do, you can take a few dimensions to make sure how good is the Ordnance Survey digital data. Now, if you find it's within 100 mil, 200 mil, it's good enough for doing your preliminary design. And you don't have to spend a load of money trying to get surveyed. But if they want to go ahead with it, then you can get a survey in. And then at least when you get the survey, you'll get something independent to check against that survey as well.
So can you just go over that process again? What's the programs and
Well, you can get a Pro Map, Ordnance Survey digital data at the site, and you get topographic, and it comes out at 1250 scale. And you can get it out as a drawn file or a DXF. The drawn file will go into AutoCAD. The DXF will go into your SketchUp and all your other systems that will port straight in. So you would buy the Ordnance Survey digital data, which is the line work, and you might get the odd few levels as well for about 20, 30, 40 quid, depends on the size of your site. And then you can go into Google and get Google image, which is not great when you zoom right in, but if you slap that on top of it and scale it up, then what Google tells you where the boundaries are can match the Ordnance Survey, which means it gives you a good idea for going out and doing your preliminary design. But an unprofessional survey, well, it's how long is a piece of string? It may save you a bit of money, you might get it half the price, but it'll cost more in the long run because they might miss out things, they might get wrong things, you might phone them up and say, the levels are no good, you 500 mil out, it's half a metre out. What's going on? So they may come, sorry, questions?
There,
Where would you get it? Well, as I said, you've got the Royal Institute of Chartered Surveyors. You've gone there and asked them for a survey company, but they don't do lots of surveys, land surveys, they'll do more house. If you go into the Survey Association, which was in the second or third slide, Survey Association, I've got companies and individuals all over the country. And they'll have different specialists. So you'll have some companies that will do underground surveys. You'll have companies that will just do topographic surveys. You'll have companies that will do monitoring surveys. And then you'll do companies that will do the whole lot. So they'll do engineering, monitoring, underground, topographic surveys, the whole lot. The thing is that if you get a company that specialises one type of survey, invariably they should be quite good at that type of survey. Because if they're still in business after a load of years, it means people are getting repeat business to keep them back. If you get somebody that does everything, you don't know who's going to do what. But the TS side, the Survey Association will point you in the right direction. And if that doesn't work, or there's nobody local to you, the Chartered Institute of Civil Engineering Surveyors can also give you. Yes, question.
Would it affect the insurance part?
Would it affect
professional surveyor be insured?
A professional surveyor will be insured. You'll have professional indemnity insurance,
Yeah.
you'll have third-party insurance, you'll have employee insurance, the whole lot. A professional one, you could ask it before you employ them to say, have you got PI? Have you got this? Have you got that? But again, the health and safety, a lot of the big companies will have to get accredited for health and safety as well. So, you know, this is how he's managing to save money because he's not paying out thousands a year. You know, we were paying £30,000 a year for our instrument insurance at one time. So it becomes very expensive and you've got to build them costs into your charge out rates. So if they only do it, and again, the availability, if you phone them up, they says, oh, I can do that tomorrow. You think, wait a minute, that's great. But whereas if you phone up one of the other companies, they say, oh, I can't get in there for 2 weeks or a month or 2 months. And you would need to balance that with some other company, you know, because you wanted 2 or 3, 5 quotes, which seems a lot of effort, but you'll be surprised at the differences in prices and what they can do and when they can do it and when they get the deliverables to you can be quite a shock. Because again, it's an unregulated industry surveying. It should be like Australia and America, it should be regulated, which is why people use RICS thinking because that's chartered, it's an institution, it's regular. Well, yeah, the guys that work for chartered, but I've picked up loads of surveys because the clients that have used RICS surveyors have been, again, Andrew Wilson, shite. They've been no good at all. Now, there might be, I've got loads of letters after the name and they're part of a big industry, but the survey, the knowledge and land survey was rubbish. So I picked up work. And one of them was through Barrett Homes. Barrett Homes at one time was the biggest building company in the UK. And we worked for about 8 or 9 regions. So with North London, South London, the whole lot of them. And I started with Barrett's at Oatlands in Weybridge. They were doing a survey and I went in and said, look, we're just starting up as a survey company. Can we do any work for you? He said, we've got a survey doing here. And the bloke's slow, quite expensive. And what we've seen so far is not right. So can you go and redo them? So we went in there. A week later, we'd done the survey. I produced the goods to him and he said, blimey. He says, where's your invoice? And I paid me. And he used to pay me on the button all the time. And this is a major building company. I couldn't believe it. I thought, wow. And he outed this RICS surveyor and used us. So that was it. We never used to advertise at all. We just got work and recommendation referral all the time. So because you used a professional survey, don't be blinkered that he's going to be super duper and you're going to pay through the nose for it. You need to find somebody that somebody else has used that producing a good quality. And certainly if you're working with a large company, they should have people on the books. But if not, then, you know, at the end of this, it shows you my company I used to have, and they will certainly give you a good central ballpark figure and give you a reasonable time frame, and you'll get a good quality survey at the end of the day. But this stuff, as I say, it could be positions of boundaries could be wrong. They may have got the neighbour's boundary who have put up their own fence, but the boundary, which is the legal boundary, which these people have not established, the survey misses it. So you go then and do stuff regarding their boundary, and yet there was another boundary 200 mil inside it, and the survey company missed it because it could have evolved, or it sent down junior surveyors that didn't want to do it. So it can catch you out. But all I'm saying is be aware. All right, it's now 11:15. Will we stop for 15 minutes and have a break?
Yeah.
Is that all right with the online students?
Yes, that's lovely. Thank you very much. Thank you.
So I was talking to a few people about the Cambridge Cottage survey, and that chap who went out with his iPhone and videoed. What we get? Bit of echo there. Wait a minute. It's all right. Okay. So what he did is he videoed round the end there, and then came back and did this bay window area there. And that's what I measured out with the 1.6 and that doorway there. And it was brilliant. So his LiDAR on his phone was great. But this is a Cambridge survey. And Andrew Wilson, when I drew it all up, you can see the north point there. Because again, as a surveyor, we will survey the land relative to north and plot it as it is. He said, oh, I don't like that. Can you rotate it so that the building is 9270, so it parallel to the sheet edge? And that's something to think about when you're ever doing your own work. It just makes it nicer to look at. So I said, yeah, no problem. So right at the computer system, rotated the survey, whacked it back out. And then I screwed it. He said it was shite because I forgot to do the Ordnance Survey grid lines, which were in an off layer, frozen. I think I could see them, but I'd locked them, so you can't manipulate it if it's locked. And then he came back a little bit later and said, no, we need to survey down here where the ramp is. I don't know if you've ever been to Cambridge Cottage. There's a ramp over there. It's a disabled ramp, so that somebody who's in the cottage for a venue, for a reception, or whatever it is, wants to use the toilet. They can't go in the main building because there's steps there. So the only way is come outside, down the ramp, and then floor level at the toilet. Problem is the ramp doesn't adhere to health and safety rules and safety and all the rest of it. So I think one of your challenges, if you still use this site, is to, all right, you're going to redesign planting all around there, lovely, but what do you do about this area? How do you get around that? So I surveyed it all and then added it to the drawing. And the thing is, because you're restricted, if you make the ramp at the inclination that it's designed for and the width, you will block the entrance into the building. And because it's, I don't know, is it listed or not, but anyway, it causes a real problem. So it's a real issue, and how do you get around it? And my suggestion was you either make it circular or you pull it out here and down there. But anyway, that's an issue. So this is the survey that I scanned, and I wanted to take a drone survey of it all. And I got restricted because of Q and because of health and safety and a whole lot of it. And I asked the School of Horticulture if I could fly the drone for the sunken garden, which is what the students use to do their final drawing. And if they allowed me to do that, I was going to nip it up here, because it's down the road, and then fly that as well. Because it would be great for you to see, you could, in the back of this is the Pro map, so I bought the digital data for that. And you can see the line work up there, the top. Let me go zoom in a bit. Maybe zoom in a bit. Up there, you've got the back of the building. Now the grey line is the Ordnance Survey. Up here is the, can I get me laser thing? Oh, disappears. But anyway, this is rubbish. Or is it me? Anyway, laser pointer. Come on, there we are. That bit up there lines up with my survey pretty well. And if you, I don't know what systems use. I don't know if SketchUp can do it, but you can switch off the layers and just leave the Ordnance Survey digital data on, and you'll see that it's pretty close to the line work round there, right? So I wanted my survey, the digital data from the Ordnance Survey, the scan data, which I mapped on, and then drone data. And it would have given you 3 different types of things that give you quite a good understanding of what you can start off with to give you something before you actually commission a full survey, either by doing it yourself or through a professional company. But anyway, this is the survey. And again, if you go in and look at Scan to Go on the Dropbox, you pick it up, there's a little batch routine. You can either go in for your PC or go in for your Mac, and then you can actually look at the scan data. And all you can do is, there's all little globes or little circles everywhere where the scanner was set up. And if you go and occupy that, you can actually see what we're looking at. and you can zoom on it and you can take out distances of anything. And it'd be interesting to see if you come up with pretty close to 1.61 on that, which I'm pretty sure you should do. So it's good tools. The cost of the tools to employ them and give you a site like that is, well, it's going to be based on the survey. We could probably do that in a day, so that's looking about £850 to do that. The scanner, if you put a scanner in to do it, we could do everything. But the thing is that they would have to go back to site and do a verification. So your scan costs are going to be 2.5K, and that's generally down to the price of the kit. But again, if you look at the scan data, it actually sees right through the window. So I'm surveying stuff within the building, which is interesting. But again, if you were using a scanner and they used it to do the topographic survey or the land survey, that'd be fine. But you would generally employ it to do elevations, because to survey the elevations on there, you can do it by photogrammetry, rectify it, or you can do it with scan data and then trace around the line work. But again, the scanner, if you were going to do a refurb in this whole building, you would lose it outside, along the faces of the building and inside. So you'd do everything with the scanner. And then you've got what's known as a point cloud, or millions and millions of points of data that you can join up the dots to give you the line up, which then enables you to do your design from it. Okay. But when I did this, I hopefully adhered to the survey principles. I plotted it in relation to scale, but again, Andrew Wilson wanted me to twist it round so it's still fitted. The plot scale is it's 1 to 100, right? And this is what I'm saying. You know, when you're deciding on your plot scale, you want it to fit on a decent sized sheet. So I could have gone to 1 to 200 scale for this because it's not used for design; it's only used for presentation purposes. So that survey would have occupied half the size of the sheet. So you get a little bit in the middle. So to fill out the sheet, it was better at 1 to 100 scale. If it was 1 to 50 scale, it would be twice as big, and it would have to have 2 sheets. Now, when you get into 2 sheets or multiple sheets, you've got issues on what happens around the edges to the next sheet. Do you have an overlap that you used to have in the old days? So you used to have a 10cm overlap all the way around. So the stuff was duplicated on the sheet and on the next sheets. Or they used to do it, which is edge matching. Edge matching is fine, less onerous on drawing, verification, check, drawing office checks, etc., etc. Trouble is with edge matching is you're going to get half writing on one sheet and half the level on one sheet and the other sheet. So so if you can get it all in one sheet, it's by far the best. So if you were doing the survey requirements were for the working in this area, then you could at least go to 1 to 50, maybe even 1 to 20. But you need to instruct the survey company what you're going to use the survey for, because a 1 to 20 survey, you're looking at a few millimeter accuracy. So when he's out surveying with his instrument, picking up that wall, for instance, he's got to make sure he's getting it within a couple of 3 mil. That's quite hard. It's certainly much harder than if that was a 1 to 500 survey, where you're allowed 150 mil error. So if the surveyor was 150 mil wrong on that inside corner of that wall, you would never determine it by the line work, because the line work is 150 mil wide, right? So plot scale has an impact on what you can measure, your accuracy, what you can measure, and how do you collect that? You know, if it's fit, go on.
Does that mean that you need to determine when you employ a surveyor exactly what size of paper you want, so that they can work backwards and pick the right?
Well, they might advise you what plot scale. So if you had this site to do, I would personally advise you to go and pace from there to there and there to there. So you know how many meters it is. And you know, or you should know, and if you don't know, you can find out in the handouts, what does that, how many meters that occupies at different sheet sizes, all right? So if you know that that would fit nicely on an A1 size sheet, you could say to the survey company, I'd like it on 100 scale on an A1 size sheet, cheers. And I would like the building orientated, the face of the building orientated to 270, so it's twisted. So then it should come back with the north point twisted because the sheet's been twisted round, and it will fit nicely. But again, if you wanted, as you say, you're doing a design round here, and you want a more defined, so you can actually put your specific plants in, then you'd want that at greater scale. But you could mention that to them. This area in red, I would like that at 1:20 scale, please, because we need to do design. They might then come back, well, actually, we're surveying this at 100 scale. That's what you're going to pay for. So we will blow up that area at 1:20, but the accuracy will be down to that. So you can't go back to them and say, actually, that wall's 5 mils out of position, because it's 100 scale, which is 30, 40 mil. Yeah. Okay. Because I said it was 150 mil at 1:500. This is a fifth smaller. 5 into 150 gives you 30 mil. So the line work you can scale off of that drawing is no, you can't get it better than 30 mil. All right, because you just can't get it. Yeah, question?
The typical scale that garden design would ask.
Well, it depends on how you're planting. It depends on whether you're getting down to minute detail or it's just a general oversight. So you're going to say, right, I'm going to pave that area. We're going to have seating along there. We're going to have raised planting over there. We're going to have pergola in the middle. We're going to have a water feature at the back. You're not going to get down to a few millimetres. It's going to be plus or minus 50 mil or something. So at the accuracy of this scale, which is 30 mil, let's be fine. But again, if 1:100 gives you a survey, a tiny wee survey in the middle of an A1 size sheet, you could reduce that down to A4, A2 or something, or A3. But again, if you wanted for clarity, you would say, all right, I'll have it at 1:50, please, on an A1, so I can see what's going on. But the accuracy, you could still pay for the 1:100 accuracy, but he's displaying it at 1:200. But they should put a disclaimer on it that this is commensurate to the plotting scale that was requested, 1:100, whatever. So there's a friendly survey company should do whatever you want. Another question?
Does it cost different amounts for different accuracy? So if you specify.
Yes, basically. Yeah, the accuracy.
Do people ever say, do the whole site at a larger scale, but I want detail on different areas?
It's unusual because the surveyor would need to instruct, or the company would need to instruct the surveyor. This area is 1:100 scale. This area around here is 1:50. This area over here where we're going to put the a new ramp, we want it at 1:20. So we get 1:20, 1:50, 1:100. It gets confusing. But the survey equipment that's used today, so the total stations, the scanners, the drones, generally works in very similar accuracies. They're down to millimeters, they're down to certainly the angles of arc. But again, the drone's not going to use angle arc, neither is a GPS, it's only surveyors. So it's all pretty much a muchness. So if I surveyed that wall out there with my instrument, which is 1 second of arc, 1 millimeter in distance, I'm going to fix them to whatever they are. Now I can reproduce that at any scale you want. If I produce it at 1:10 scale, you could then measure from there to there and say I'm 2 mils out. And then I would say, well, hang about. I'm allowed 3 millimeters at 1:10 because it was 30 mil at 1:100. So I would say, you're saying it's 2 mils out. I'm saying it can be 3 mils, which is the thickness of the pen line. So it's all right. But I did have a boundary dispute once with a client. I don't know if it was Barrett's, but it was a bit major house builder, like Taylor Woodlow, Press Nicholson, Beezers, Persimmon, somebody big. And we did the survey. I didn't personally do it. Another surveyor did it. And this director phoned up of planning or director of construction, whatever. He said, David, I got an issue with your survey. I went, oh, here we go. Hope the PI's all right. And he says, the differences in this corner are 3 and 4 millimeter different. Which one's right? And I thought, wait a minute, is he being serious? So anyway, I pulled up the survey and it was a corner of a building that he was saying 2 or 3 different. Now remember that we'd probably done the survey at 1:500, but possibly at 1:200. We might have done 1:100, but if it was a boundary dispute or it's an area, they generally used to getting the surveys at the scales that they have. So I went back to him and I pulled the survey up. I says, actually, this survey's been produced at 1 to 200, 1 to 500, whatever it was. I said, and you're saying the corner of this wall is, there's 2 or 3 there's 2 or 3 points in it, and they vary by 2 or 3 millimeters. So what he'd done is he'd zoomed into our survey, and lo and behold, was 3 little crosses on it in the corner. But you would never look, you'd never see it when you were right outside. It's only when you zoomed right in. Because just this little area of crosses looked thicker than somewhere else. So he zoomed in 3 different crosses, and they were 3 mil different. He says, which one do I use? I says, well, to be honest, I didn't want to say you're taking the mick and you're shite. But what I did say was, well, at the plot scale, we're allowed 30 mil, 50 mil, 150 mil. I says, you're asking about 3 or 4 mil. That's probably where the surveyors used a laser-based distance to get in there. One bit he's hit the brick. The next time he's observed it as a check, he's hit the grouting between it, and the grouting can either be outside or inside. And the next one was another brick low. So the bricky was probably out by a couple of mil, but it was the difference between the grouting to the face of the brick. And I didn't want to be rude, but I just thought, are you having a laugh? You know, that's it, mate. Sorry, you know, we're not going to redo the survey because the survey's fine. I've had 3 points in it that I've proved that, they've verified that point is fine. There's nothing wrong with it. But if you want us to redo it, we'll review it and I'll look at the survey. And to this day, I don't know whether he was being funny, taking the mick, or he was just didn't understand. And I think it was a didn't understand bit. So a survey will be collected at what the availability of the resolution or the definition that the particular equipment the surveyor uses will be able to give you. And that is up for debate. So it's what you're going to ask him is, what sheet size do you want? And what plot scale do you want? And obviously, once you get some experience in it all, you're going to then decide, actually, 1 to 100 scale is fine. Or for doing my preliminary work, 1 to 200 would be fine. But again, what's the point in doing the 200 if it's going to be a tiny sheet? When eventually you're going to use it at 1 to 100, you might as well go for 1 to 100. But you might want areas that are bigger. But the trouble is, if you get 1 to 50 or 1 to 20 surveys, which is fine, you like using it because in a small garden it's great and you can see what you're doing, you can measure things, and you can put your little plants in, and it's all lovely. When you then go to a bigger survey and you say, hang about, I quite like that 1 to 20 scale or 1 to 50, and it's that size, you're going to end up with multi-sheets. Then you're going to end up with edge matching, or you're going to end up with overlap. And then it becomes not so manageable because you've got all these little bits. So therefore, you're better asking, can you give me this at 100 and give me these specific areas at 1 to 20, 1 to 50? And then ask the surveyor, if I want to come back to have another area, that's well, can you do that? And generally, they should say, yeah, for a small charge. All right. So pace your site. Find out what's the plot scale you think you want to work to. So what's your accuracy? If your accuracy is 5 or 10 mil, then you're going to need to 1 to 20, 1 to 50. If your accuracy is 30 mil, 40 mil, 50 mil, 1 to 100 is fine. If your accuracy is going to be 100, 150 mil, you're not bothered. And 1 to 500 is probably fine. But they won't be able to show all the gullies and the downpipes and stuff like that. All right. So again, and there is details, there is information in the handouts in the portal, the Dropbox, that gives you some guidance and all that. All right. Benchmarks. So this is a nice cut benchmark, right? They were used way back when, and when they mapped the UK, they put trig pillars, which is this thing up here. No, it's on the next one, sorry. They used trig pillars to map the whole country by trigonometry, triangulation. And what it is they had a baseline, measured the baseline as accurately as they can, and then from their 2 points, they took lots of observations, lots of angles to points all over, went to France, went to Ireland, and mapped these, right? So they were using very precise instruments that are down to 1/10 of a second of arc. And they had heliographs, which were mirrors that you looked at the sun, you reflected it, and the guy on a hill 20 miles away could see you flashing. And he knew that's where the survey point was, and he could turn his angle to that and take a shot. So they did multiple rounds of angles, 10, 20, 30 rounds, and then they would mean that all down, and they'll get an angle from point A trig pillar to point B trig pillar to point C trig pillar to point D. And they did that all over the country. And as I say, went to Ireland, they went to France and mapped it all. And it wasn't that long ago now that they got the GPS in to see how good all this stuff was. And the mapping of the original trig network that was done with 200 people probably, you know, because there was loads of people, it took months, if not years to do, was down to not very much. It's even Everest, the height of Everest is only within a few feet, as it was bloody 200 or 300 years ago they got it. So old survey methods, principles and old survey methods are pretty good. To get the benchmarks, they had these trig pillars. So then they leveled them and they said that's the primary network. And these were metal brackets stuck on the side of the trig pillar. And then from that, they then measured the country and they put these probably every 100, 200 meters all over the whole country, on churches, on railway bridges, people's houses and whatever. And that one there is the one that's across at St Mary's Church, St Anne's Church in Kew Green. And it looks a bit damaged, it's weather beaten, but it was originally looking like that, nice and clean and tidy. But it says there are 750,000 benchmarks, Ordnance Survey benchmarks established from 1840 to 1985. And I stopped using benchmarks probably 20, 30 years ago. They don't display them on the maps. There's a little bit of the T marks for boundaries. The Ordnance Survey stopped displaying them because they didn't want to maintain them. So if they put a mark on somebody's house or a bit, and somebody used it and then checked to another one and said, hang about the difference between that benchmark and that benchmark is 20 mils. It could be that the ground is swelled or shrunk, or it might be that it's almost within the tolerances that they allowed at that particular time. The Ordnance Survey, as an institution, has got to come back and comment on that and say which one's right. And the only way they can do that is to re-level them. But they don't want to spend the next 20 years re-leveling 750,000 of them, because a lot of them are going to be destroyed anyway. But you can say that you've used a benchmark against another one, you've proved it's quite good, and then they will say this has been used and proved, and they'll actually make other people aware of it all. But it's something that's not used very much. And it was the whole lot was based on the mean sea level at Newlyn, right? And what they did is over an enormous amount of time is they measured sea levels, mean sea levels for neap tides and the other tide. So there was two extremities of the tides. They meaned all that. They did it over years and years, and they said, right, we're going to call that as mean sea level. But there was one up in Liverpool, and there was one somewhere else as well. And the thing was that they had to establish a datum that everybody could use. So they used Newlyn sea level datum, and these benchmarks were all related to that. When GPS came on the scene, it's a worldwide thing. So for the UK, they said, are we going to use mean sea level? Well, we should do, because otherwise the maps are all different. We've got to change it because the datum's wrong. So what they did is they formed a geoid, or a fictitious sphere over the UK part of it. And the GPS heights that you get are based on Newlyn, but given this geoid, this fictitious line above sea level. And I've checked a lot of the benchmarks against the GPS, and they're somewhere between 5, 10, 20, 30 mil, 40 mil out. So it's pretty good considering. And again, as I said, you don't know if these are varying by 20, 30 mil because of subsidence, because of movement in the buildings, because nobody's checked it for 60, 70 years. So they stopped checking them all, I think, 1980s, 90s, 90s or something like that. So certainly 30, 40 years ago.
Sorry, and what does the benchmark actually show?
It gives you a level above sea level.
And is it noted on them what they are?
If you find a map with it on it,
yeah,
it'll be written on it. And if we go back a few slides, on there, yeah. On there, there's a benchmark on there, and it tells you the value benchmark 29.43. All right, that's some feet. All right. Yeah, so we go. So, yeah, it's a height above sea level, right? And that's, so if you use that and it comes up to 20, 30, 45 or whatever, that's a height above your sea level, right? And all the drainage, manhole covers and inverts are all based on that. So if you've got a major trunk sewer running through your site and you've got manhole cover levels either side, and you'd probably be able to find it from the statutory undertakers, the invert level to the pipes, it's all based on that. So when you're doing your survey, if this is going to be a concern of yours, you want to try and find a benchmark or come off that manhole cover, level to that manhole cover, and then close it out to make sure your leveling's good to find out the values given for that correct. If they're within 20, 30 mil, accept one of them, say that's your datum, come on to site, relate that level value as a datum to the floor level of the house and 2 or 3 other points on your site. Because when you dig down 2 meters to put your water feature in, you don't want to hit that trunk sewer. And the only way you can determine how deep it is off the information given on the cover levels to find out the invert level, to find out where the pipe is, to find out the gradient, so you don't dig down and damage it. Because if you damage it, it's going to be a huge knees up, all right? And there might be the odd time that you come across this. But again, from the deeds and all that, there should be something known as an easement. And an easement is a clearance on the ground that say you cannot build within 2 meters, 3 meters, 5 meters either side of this sewer run that's running round about. So you would know it was there. It would be written on the deeds. The client might not even know it's there. It's something that you found out, same as your T marks and your right lights. Now you found that this trunk sewer runs with it. I'd love to do your design with the sunken garden and what have you, and then, you know, underground swimming pool, but I can't because we've got a trunk sewer running through there, and I can't damage it because there's an easement. It's illegal to get done. So it's all useful information. You don't want to be getting down the road and saying, "Yeah, we'll do this, we'll do that," and then you find out, think about it, somebody says you can't do that. So benchmark's quite important for the datum, and if not, then there'll be some relationship to somewhere else. So that is a trig pillar, and yeah, if you zoom in it, there's a little indentation on the side of it there, and that's probably where the bracket is. And the bracket is, I used to use a 50p coin or 1 penny, and I used to put it on the bottom of the level staff so I could sit it on top of the benchmark, either on the cut line or on top of the bracket. And then the surveyor would read it, because you couldn't get the staff in there because they protect it so it doesn't get damaged. So you had to use something to get into the cut mark and that, so you could set your staff on top of it. But that's it, and that's the St. Mary's Church one again, which is in there, and that's a bit of odd one as well, because what I did was get out of that. I went over St. Mary's Church because I got the Ordnance Survey digital data of that area, I think, or I looked at it, and it said there was a benchmark on the bit that sticks out, right? There's another extension out the side of that church. Yeah. And yet this said it was near the doorway, the entrance. So, and it didn't show anything on the map. So this is what I'm saying about the Ordnance Survey not updating things. So it might have been there. The Ordnance Survey haven't updated it because they don't want to spend a lot of money doing it. The latest one they had was stuck on an extension, and I spent about half an hour hunting for it. I couldn't find it. Now I'm a surveyor, so I don't know what chance I've got, but I could be blind and need to go to Specsavers. But I couldn't find it. So benchmarks are okay if you can use it. But if you're going to get employ a survey company, he's going to use GPS, which is based on benchmark information anyway, and you can use that. If you're doing a little garden survey on your own, then just use the ground level as your datum and give it 10 meters, 20 meters, 30 meters, or whatever. Doesn't matter. Because you can always relate that to Ordnance Survey benchmark values and the OSBM values later on if need be, because all you do is just move your site up and down to match it. You know, if you do a survey first off and then it gets extended and you employ a survey company to do it, you can then say, can you put a couple of levels on this bit because I need to raise my survey to match your survey. So it's all the same. So, you know, you can get around it. So as I said, try not to use the zero data. And I've had some architects that love that. And the trouble is, when you're up in London, they're doing stuff and then they'll spend millions doing underground living accommodation, staff accommodation, swimming pools and things like that. And they've given the floor level of 0 because they think it's clever and it suits them. When you get underground, there are minuses. And when you're dealing with the minus here and the minus there, it can get quite confusing to find out, because you've got to take one from the other to find out how thick that lintel is or the floor levels, or it just becomes a nightmare. So try and avoid using 0 data. Because it'll just give you headaches further down the line. And that is a little image of my laser. That's the scanner set up. Let's zoom in on that. So that's the scanner set up. That's me. The points that I observe to find out the position of that. And I've 4 or 5 or half a dozen of them set up everywhere. And at every setup, I observe them before I move it, and it finds out where it all is and knits it all together. But that, I think it was either that door or that door. So it was either that door or that door, which is the one we measured. But if you look at, as I say, if you've got time, look at it, because it's quite interesting. The scan data and what you get. If you've never come across scan data or point clouds or anything, it'll give you a little bit of understanding what it looks like. So your survey, what's it going to contain? Well, it'll contain anything that you want it to contain. So if you're only interested in, I don't know, the relative position of the main building and the boundaries and a few levels, because you're going to rip everything else out, that's all they ask for. But generally, it will ask you, you can get buildings, sheds, trees, vegetation, boundaries, artifacts, services. This can be anything. So you're looking at stop valves, gas valves, water meters, surface water manuals, inspection covers, foul water, or whatever. Access, there could be access to basements or whatever, so there might be a little window or a door. Again, you don't want to be, you want to have that on your survey because you don't want to be doing anything else to block it up. Because you might be blocking up, which will then introduce damp errors, or you might introduce the lack of light, right of light to the basement. Even though it's your client, he still wants that light downstairs. So overhead fires, very important. If you're bringing in established mature trees, you don't want it snagging on anything overhead that wasn't picked up in the survey. And that can be cables, BT, pipe work, whatever, even over large overhanging trees. So it's anything that can get in the way of you bringing stuff to site that you would need on the survey as a record, so you know it's there. Because generally people, surveyors and everybody, be walking about looking at ground level, we're never looking up to see what's going on up above them. Levels, as I say, your levels are very important. And some people say, what grid do you want? And you're thinking grid. And you're thinking, is it a 10-meter Ordnance Survey grid? Is it, you know, this is the line work on the drawings, that if it's coordinated, you need a grid to draw it from. But what they're meaning is, what level grid do you want? And a level grid is set distances between the level from the furthest other level. So if they say, do you want a 5-meter level grid or a 10-meter level grid? What they're actually saying is, between one level point and the next level point will be no more than 5 or 10 meters. All right, so they're not talking about the line work on the drawing, they're talking about a level grid. And they will give you sorry,
The,
repeat it. Yeah. If they say to you, what grid do you want on the drawing? A grid can have two parts to it. One can be the line work. If I go back to that one, the line work, the grid on here is that big line there, and these little ticks, one there, one there, one there. That's grid intervals, right? So if somebody says, do you want a grid on it? That's one there, and one over there. That's the grid interval, right? So if you said, what grid do you want? They might be saying, do you want 100 meter between it? Or 10 meters between it? Or 20 or whatever. But anyway, so that doesn't mean anything to you, really. It means that when you come to check the survey, you can measure, you know, that's 100, well, it's 518900 eastings, all right, from its origin point. And that's the Ordnance Survey origin. So where the origin was, I don't think it's Newland, but it's probably way down that way. So you can measure from that grid line to that and see, and say it's 518900, whatever, how many meters it is from there to that IC. So that's what the term, surveyor's terminology is a grid. What grid do you want? But what you're talking about is a level grid. And the level grid is different because the level grid is the spacings between levels. All right. So if they're talking to you about grids, ask them what grid do you mean? Level grid or drawing grid? And then they'll think, blimey, this person knows what they're talking about. Yeah, does that make sense now? No.
hopefully.
Hang in there, hang in there. So anyway, the level grid is how much. Now they're going to give you extra levels along the boundaries, along the tops of banks, the bottom of banks, the walls, the base of retaining walls, top and bottoms of curbs, etc., etc., etc. So where they would say, I'll give you a 5 meter grid, they should give you a 5 meter grid. So it's like giving points every 5 meters on a square all over the site, but they'll give you lots more for the covers and the tops and bottoms of walls, steps and everything. So, but if you think that the ground is quite undulating and you want to do some remedial work, some design work, some changes of level, because you want to change that embankment, flatten it out and move it, then you want a bigger level grid. Oh, sorry, a smaller level grid. So you want it down to 2 meters or 3 meters. Or even a meter in some areas. So you get a level point every meter, which is a huge amount, which means you then know exactly how that land is lying. And from that in the contours, you'll know exactly what you're doing. So you say, right, I want this level to bring that down to there. I can take that material. So I need to, from that point, I need to go down 350 mil. And from that point, I want to need to go down 250 mil because you've got a good level grid. Whereas if you've got levels outside that, you've got to make some guesstimations. So a smaller level grid, more levels is quite good. And to be honest, it shouldn't take the survey company very much more time and effort to do it. Because all he does is walk about with his little pole, or he'll scan it, or he'll use a drone, and he can pick off anything they want. So levels, go for the smaller one that you need. But again, dependent on the site. Again, if you had that garden, so what you wanted was a house, the fences at the back and the sides, 5 levels, 1 at each corner, 1 in the middle, either side of the house, job done. Because you're going to strip it all off. So it doesn't really matter because you're going to reduce it all. But where you're doing bits and pieces of existing gardens, then you probably want a greater amount of levels on it. But again, that again comes down to your plot scale. If you go for 1 to 200 or 1 to 500, and you've asked for a 5 meter grid of levels, you're going to have the whole thing's going to be covered with levels. Too much. So again, the level grid can relate to the plot scale, can relate to the sheet size. All right. Just to confuse the issues. And then from the levels, we can produce contours. Everybody know what contours are? Yeah. So contours are very, very good at giving you a quick feel of what the ground's doing. And remember, the values for the contours obviously run uphill. So if you look at all these squiggly lines going about, as long as they've annotated the contours correctly, you can tell where's the rises, which way is it going very quickly. And certainly if you're doing ground maintenance, you wanted, because the client said it's all floods over there when it rains a lot, you can then bring in some ground drainage and get rid of that to soak away or whatever. And the contours will be very useful to determine where this collection of water is going to. All right.
Can I ask a question about terms in general, for a typical sort of London garden, residential, so you might be, I can't get right on the back garden done. Would you also get the front garden surveyed at the same time, just for overhead wires, for services, for all of that
If
stuff?
you were employing a survey company, yes, it's probably just easy to get them front and side and all that, because you're going to tell them to do the adjoining windows as well, certainly at the back. But it depends on the size of the front garden. If the front garden's substantial and they will, once they've done the back bit, going to do the front bit, then yeah, by all means do them. But if it's only a metre or two, you could get them just to do the building outline, the back of path, what the boundary is that wall, is a hedge, face of the curb line, and probably go 10 metres either side, drop curves and everything. Is there any yellow lines on it? You know, things, because if you're bringing a truck by, and it's a very busy road, you want to know what the restrictions are. So again, look at lamp poles and seeing what the parking restrictions are, just as well as looking for overhead wires and cables and trees and all the rest of it. Because if you want to get your materials down the back, you need to have a clear way to get down the back. So yes, from a survey point of view, if you just get the right line round the back and the front garden, the cost is probably going to be the same as what it would be for the back, because their effort to get to site, to get the equipment, to survey it all, to draw, you know, for an extra hour or two in the day. So it's 6 hours or 8 hours. It's not going to matter very much at all. But again, as I said, some companies will charge you different rates. Some will do an hourly rate, some will do a field rate, an office rate, a processing rate. We just did a day, regardless of what it was. But if it was in Scotland, we'd say, fine, but we need to add on mileage to get there because it's going to be quite a bit. We need the travel time and we need the accommodation. So they're the extras. And failing that, if you didn't want to use us to do it, you get a survey company up in Scotland to do it. But they may not give you what they want because you've used us 10 times. You know what we're going to give you. All right, so it's this idea, but at least you're thinking about it, which is what you want. But yes, I would include the front garden as well as overhead wires and everything. Scale and accuracy. We did touch on accuracies. We were saying 150 mil at 1 to 500, 30 millimeters at 1 to 100, and then you obviously work it out from that. So the order of accuracy, if you're getting the Ordnance Survey digital data, and Google's and all the rest of it, is land surveying obviously is always going to be the best. And whether that's by conventional means or whether it's by photogrammetry, LiDAR through drones or scanning, as long as they've done the ground control, the stuff to make it fit, then that's going to be your number one that you can use. The next one is your Ordnance Survey digital mapping, and you get that from ProMap and other people, and that will give you generally 100, 200 mil errors in the boundary, or what it thinks is the boundary. And remember, this was all done from aerial photography in the 1920s, 30s, 40s, or whenever it was. So where they see a hedge line, they might not see a fence that's under the hedge line. So all they'll do is determine the center of that hedge line as the boundary, because that's all they could see from the sky. So even though you're using Ordnance Survey digital data, the line work should be pretty good. So if you measure from there to there, and it's half a metre out or a metre out, that's because what it was when you photographed it. But it means that you can then move one of the boundaries in, right? But you don't know which one. So then you measure the house, excuse me, you measure from the house to the boundary at this side and the house to the boundary at that side and find out which one's best. And then start your preliminary drawing by correcting that line work from the Ordnance Survey. And then the next one is Land Registry Title Plan, which this one is 1250, but you used to get a lot of them in the country for 2,500. And at 2,500 scale, it's about that much accurate on the landmark. So if you do that in one boundary and then the other boundary, it's quite an area. But it's all right again to give you a guide. Another question? Go on.
Sorry, it goes back to your previous slide with the T's and the H's.
Oh yeah.
So this is quite live for me. I literally bought my land registry title plan for my house like 2 weeks ago.
Wow.
Looking for my boundary. Because in our head, we own our boundaries, but we're just trying to confirm whether that's true. There's no mention.
There's nothing on the plan.
No,
And is there anything in the written deeds?
not that I saw when I skimmed it. I thought it was a bit dull, but yeah, so it's
We'll have another, it's usually in the first couple of sheets. It'll tell you what
there's nothing on the map, so like if that.
well, that's what I'm saying. A lot of them didn't have it. It's only the older ones used to put T's and H's on it, and H's are even once in a blue moon. But if there's nothing on it, there's nothing on this one. That's my daughter's place. There's nothing on that. Well, well, she. To be honest, I can't remember what I looked at. But again, I wasn't thinking about that. I'm just thinking about what do I need to do for her, you know. I do know that boundary along there, I think, is the neighbours, and even that's the top of the embankment, because I've got, if you remember the other photograph, of the structure. So she's got the structure through there. So I'm assuming, structure there, assuming that they own that boundary, right? There's a big brick wall there that's a retaining wall. It's about 10 metres high. Not sure. This one, they've got the good face against it in between brick pillars. So I'm assuming they own the boundary. So she's owning that and possibly that. All right. So you need to look at your boundaries and what you haven't got boundaries. Hedges, right. Have a wee look in the hedges and see if there's any iron posts or anything near the root line. No, nothing. All right.
Anyway, yeah, I guess it's something that can happen with required, right?
Well, if it's part of a terracing or whatever, or even a row of houses, generally the one at that end might have the left hand or the whatever north, south, east boundary. And then the neighbour will have the next one, and the neighbour will have the next one. And then on the end, the last person will own that boundary and the outside one. All right, so they'll have two, whereas the first person's only got one. And the back boundary could be theirs, or it could be part of an access way or a road or whatever, that it might be a highway boundary, so that's already been established. So it is, but if you haven't got the full written deeds, then these are probably quite a few pages long, because it'll go into what you can and can't do. You can't make clay bricks, you can't do this, you can't have caravans on site, whatever. Within there, it might tell you you need to maintain your fences at all times. And if it says that bit, maintain fences at all times, somewhere in there it's east, west, north, south, or it's 50 metres from there or something. There must be something in it. Failing that, you can go back to your solicitors and say to them, you want to do some work in your garden, but you don't know which boundary you own. Can you please tell me? And they probably want to charge you, but you should tell them that should be part and parcel. You know, how can I buy a house and I don't know what I own? Yeah. But it should be written somewhere. And you could first question ask them, have you got any written deeds? Because what you get on land registry is sometimes not classified as the written deeds. They're just the title plan and notes.
Yeah.
All right.
And that comes from somewhere else.
Land registry, there's 2 or 3 places, but generally that's where somewhere down south they keep a big load of them. And they're historical, so all they do is lodge them. And failing that, when you bought the house, how long were the owners in there before you bought it? You could ask them. You know, if they were there for... Yeah.
So my neighbour grew up in the house.
Well, there you go. They may or may not know. It's something that you say to somebody, what's your boundary? They just, what? You might as well ask them how far it is to the North Pole. But it's worth trying. So worth trying solicitors. Say you've got the title deeds, you've got the title plan, but there's nothing in there about boundaries. But have a wee look to see if it says anything about maintaining it. And if not, then say, have you got the written deeds? Because I want to know what my ownership is and my boundaries. If he says, I don't know, I said, well, you should know. You've just sold us, you know, you've handled the sale of it all. And then ask your neighbours or the person who had the house before you. Because they might have planted them, or they might have been established there from day one. It depends whether it's a old hedge. You just don't know. But yeah, ask is the idea. Ask historical information. All right. So again, this is the West Digital data area. That was a land title plan. And this was blown up from that. So I blew that up to 1,500, whatever it was. And then did the survey, and the survey was away at the start. So the survey was there. That was a survey, all right. So that's got buttressed walls, and that one's got buttressed walls as well. And as I said, because they've got the construction through it from memory, I think that's her boundary and that's the neighbour's boundary. And I don't know without looking at the deeds what's happened at the bottom.
I actually don't know how to read any of those numbers. Do you cover how to read the?
How do I do something?
I don't know how to read that at all. Do you cover that in your presentation, how to read?
Yes.
Yes.
It's just a load of numbers, isn't it? And squiggly lines. But again, that's what's saying about the level grid. So if you ask for a 3 metre level grid because you want the land's boundary bumpy and you want to get it up, and you've asked for that at it looks 150, but I'm not sure if it is. And you get 3 metres, you might have another level there, another level there, another level there. You're going to get more writing on it. And then it gets, whoa, hang about. So you need to expand it, make it bigger. So again, there's a lot, you know, there's no fixed way of doing things. It depends what you want on the survey, what's the plot size, what's the sheet you want it on, and then what kind of information is it going to be useful. And certainly if you scan it, if the survey company scans it or does it by a drone, that's a snapshot of that particular moment in time. So you can go back and get extra information. If I went out and surveyed it, I'll only collect what you've told me to collect that day. So if I didn't get that gully out there because you didn't ask me for it, I wouldn't show it. I'd need to go to a revisit site to get it, unless I took photographs. And if I took photographs, I've had to count bricks to find out how far it is from that wall. So again, what you employ depends on whether you can do things. But don't be obsessed about thinking that you need to scan it or get an aerial, a drone survey from it, because it might be unnecessary. What you want is the stuff that's important to you. But you're going to know that anyway. You know, when you're doing your design, you walk out of the back garden, you've got to think, this could do with a bit of that and a bit of that. And then your client's going to say, I want this, and I want that, and I want that. And immediately you must be thinking, right, I need to survey that. I need a good grid of levels over that, and I need that. So immediately you start to build up what you're going to ask the survey company to give you, or at least you're thinking, I need to make sure I've got the wherewithal to get that. That's nearly 12:30. Shall we break for lunch? Because this goes on a few more slides on how to go about surveys. So if we have a break now till, was it 3/4 an hour? So
Rushing it right now.
okay, we're this is going to be, if you're going to tackle some surveys on your own, this is an approach you would need to adhere to. All right. I mean, I'm not saying that everybody is going to attempt to do a survey on their own, but certainly if you've got a little background, a back garden in London, then it would work up my class with it, because certainly starting off, if your client's not prepared to pay for professional survey, you're going to have to get out your tape measures and do it yourself. So on this could be a typical garden. And you want to have a good walk about it, take a load of photographs, and the reconnaissance of the recce bit is something that's invaluable and seldom wasted, because you'll see bits that you thought were square and they aren't. You might see double fences, you might see service covers or whatever that's in there that you weren't aware of. So Becky, we talked about how to fit it on an A1, A3 or A4 size sheet, which is pacing out the extent of the garden. So pace the length of it, pace the width of it. That'll give you the rough meterage, and then you can find out with the notes in the Dropbox what's the best fit to scale, best size sheet to put for the scale that you want, whether it's 150, 120 or 100. If you're banging in pegs or nails or using anything for the start of baselines, which is point A to point B, that you can go along it and the tape and then offset 90 degrees to pick up your detail. Then you can use the start points and end points to do what's known as trilateration. So you've got the distance from one type from A to B, which you should know, and then you go from A to a point of detail, and then B to a point of detail. All right. And don't sketch too small. Again, we was talking about earlier that I've got a tendency to not be as tidy as I could be, and I try to cram in too much in a sketch. And you're better off using lots of sketches because paper's cheap, and you can, as long as you note it, date it, and where the site is, then you should be able to pick up from it. And confidence measurements, which is you come back to the office, you started plotting it all up, and the things you're not sure about, you should have taken some redundancy or confidence measurements just to hold the whole thing together. And you'll get into the habit of taking more of them, because basically a redundancy is you've got extra information measurements that you can chuck away, and the accuracy of your drawing is going to be exactly the same. Nothing changes of it. So it's quite good to have lots of redundancy. But you might find that you get to the stage you're taking too much of it. So 50% of your measurements, you don't need them. But that will come after experience. And then you can reduce it and get your surveys done quicker. So basically here we have just the back of a house. We've got probably a conservatory or something, service cover, paved area, tree there, an inspection cover there, a couple of trees, and a curved pathway in the shade, and then the hedge and the fence goes round it. And we want to survey all that as accurately as we can. So people would either go along the face of the house, the building, to measure, or they'll have an offset baseline. So they could eyeball and put a nail in there, take a measurement out there, put a nail up, a mark in there, and do the same distance off that end, exactly right angles. And then you'll have a baseline along the face of the building, along the offset of the building, and then you can measure to the building face. All right, you want to try and use graph papers for sketching because it'll help you to keep it neat. And then if you're going to tabular your information, because the choice is to write it along the lines that you're measuring. And the thing is that can get quite busy. So if you annotate it as A, B, C, D or whatever, don't use 1, 2, 3 because that'll get confusing with the measurements you take. So use A, B, C, D, and then say from A to this point, that point, from B to that point, this point, that'll help. You can go along the face of the building. So he started here with a 0. He's going along, measure the window, measure the door, measure the window, and then he's got the conservatory. And the tickle. Right, okay. So this is all right for getting the positions of the windows and the door and the face of the building, and the conservatory is fine. The downside is you've got a 0. Where's me? Yeah, you got a 0 there at the start. Then you get to the conservatory, so you offset, assuming that's 90 degrees, you've got 0 again. You measure the doorway in the conservatory on the other side, come back, and then you put a 0 on there again to measure that last bit. So you get the 3 0 points. And that's going to introduce error, even if it's 1 millimetre. By the time you get to the other end, you go 3 millimetres out. If you're 10 mils out, you can be 30 mils out at the end, and it goes on like that. And this is the same concept as working from the outside to the inside, from the whole to the part. You want to minimise your errors where you can. So to avoid 3 possible error points, because the conservatory might not be built square to the building, and you're measuring to where it hits the building, and then you're going to put a 0 point on the other side. So you want to try and overcome that as possible. And the best way to doing that is have an offset chain line or an offset baseline. And this is what I was saying originally: measure off there at a set distance, bang in something or mark something up, and likewise at the end. And then you can offset to all these points at 90 degrees. The thing is, they're quite far away. So you're standing here with the Chinese type, you mark down the chainage, and you get the offset at 90 degrees to the windows and the doors. But it's quite far away. So how can you establish that that is as accurate as you can possibly get it? There's a note on there about using different colours. As I say, you don't want to use numbers for the ends of baselines or control points. You want to use A, B, C, because you're going to be doing lots of numbers, and you want clarity to know what your control or your start points are. So we've got the chain line or the baseline out there. If you swing your tape back and forward, that you'll immediately know when you get 90 degrees. All right, because once you've done it a few times, you'll find out that it is quite accurate, and you'll certainly get it within 5 or 10 mil, regardless of the distance of it. Right?
What a spin to take.
Well, the tape is at the edge of a doorway or a window. And what I mean by swinging the tape is it's hooked on there, or you got it on there, so you're moving it away. What you read on the tape's greater. Then it comes back to the centre, which is a smaller reading, 90 degrees. And then when you move it away again, the distance along the baseline, the tape that you've got on the ground, is going to be greater again. All right? So this is called chain and offset. So you've made 2 points that are opposite, that are offset from the building, and it says it's 4.7 meters off the building, and you've marked them. And ideally, you want to use nails, pegs, or some pin or something, because you're going to use that point to measure other bits and pieces from. So the first thing you do is hook on a tape on there, pull it to the other point, leave it on the ground, and use a handheld tape to measure the offsets. All right? And when you get the handheld tape exactly on 90 degrees, it'll A, be obvious, and B, it'll be the smallest dimension, because as soon as you move it away, that dimension is going to increase. All right? That makes sense, yeah? Okay. So you do that, and again, you could have picked up that IC from the face. If you do, as a redundancy, you measure along the face of the building. So you did that first one. So you did it that way, right? So you can book that down because it's easy. You know exactly where it is. Hooking on the side of the building, pull it along, measure the window, the other end of the window, the doorway, and so far, right? Use that. Now, for redundancy, or to prove that, you can do it by this method. All right? So that's your redundancy. So where you've hooked the tape on there to get that window position, your chainage is going to be along the type, and then you're doing the offset. And that should match up within 1 centimetre or less, or 2, to the one that you've done previously along the face of the building. And that's what I'm saying by redundancy. Okay? So if you use this method by swinging the tape, you'll know you've got 90 degrees. There is something else that I'll show you this afternoon, which is what's called the right angle square. And the right angle square allows you to position something. So you can go along the chain line, stand over the chain line, hold this on here. You can look at the edge of the window, and you can see the tape on the edge of your, on the other two, the top and the bottom prisms. So you get an image. So you can see the image, 90 degrees there, 90 degrees, 180 degrees there, and 90 degrees off it. As I say, I'll show you what they're like this afternoon. They're a very handy piece of kit, £40 general cost. and they can enable you to set out right angles and check things are square and aligned. So you could use that as well to make sure that you've got the correct chainage and the correct right angle. But you must always be 90 degrees to it. So you can use that method, which is chain and offset, and you can use trilateration, which is a solution of measurement on a triangle that's got 3 sides measured. And that's the most efficient way, because if you measure the triangle, so if you go back to that one, so if I wanted the corner of that IC fixed really well, I could take it from my produced point, 4.7 meters from there, take a dimension to the corner of the IC, and do exactly the same from that side. So I've got that measurement, I've got that measurement, and I've got the complete measurement along the face. So I've got 3 measurements. That would fix that, because when you draw arcs on plan or in a computer system, there's no way that the 3 measurements will be different. It won't plot it in the place that you want it. You can get a mirror image, so it could be on this side, but it's obvious that it's this side of the chain line. And again, once you've started using it, you'll get the hang of it, and it'll be much easier. So this here is a picture of a survey control station, and the tape's hooked on the top of it. And you can put another peg with a tape on it and pull that and accurately measure from these 2 pegs, and that would be your base station. And then from that, you can use triangles, or you can use chain and offset and measure in your detail. And it should be very accurate. So on this sketch under here, you've got 1, 2, 3, 4, 5 control points. This is a complex garden, but it's used 5 control points: 1, 2, 3, 4, and 5. And what you do is measure the triangles for each of the points, and you should get them down to a few millimeters. And then from their points, you can measure off anything else in the garden. And you'll probably get some quite surprising results. So where does the errors come in? Well, the errors come in if the tape is not straight or level. So you're going over walls and things like that. And again, ideally, you want to have it flat and straight from point A to point B. There is things you can get when you measure over the wall. If I wanted to measure that gully that's in the middle of that open area out there, but my control point was in the footpath at the other end. If I put it on the nail on the footpath and pulled it over here, if I pulled it down to the gully to get a distance, I've got that angle from the pathway to the edge of the flower bed, and then the angle from the top of the wall down. And when you bring them up to the horizontal, they're going to be different. So when you're plotting it on a plan, you want it to be horizontal. You can tour from measurements from the wrong point. So you've misidentified a point, and that's why it doesn't work out. So that's the clarity you need on your sketches to make sure that they're clear and easy to see. Incorrect angles, so that's what you were saying about how do you know when it's 90 degrees? Well, if you haven't got the correct angle, the point that you're offsetting to will be wrong. But you're looking for the minimum distance on the type when you're doing an offset. Or you haven't got enough information, you haven't done enough redundancy. And because you're plotting horizontal measurements all the time, it's fine when the ground's flat. But as soon as it starts undulating or going over obstacles, then you need methods of getting that horizontal distance as best you can. So on a hilly garden, or sloping garden, and it depends on the inclination of it all. Again, there's an Excel spreadsheet, and there's notes in the handouts in your Dropbox that show you what the effect is over sort of 20-meter length, 10-meter length. What if you got a meter? How does that affect the ground distance? If you got 2 meters, how does that affect the ground distance? And again, depends on your plot scale, whether it's going to cause you any problems. But you probably don't need it, if you're plotting a 1 to 100 scale, you don't need it to be very far out for you to lose 30 millimeters on the incline or going over obstacles. So again, you need to check your measurements from other places. But you can use a couple of devices to give you a change in height if it's a lot. You know, you're talking about something that's pretty steep. So you can use a clinometer or an Abney level, and they both work basically the same, and they'll give you an angle. So it's the angle off the horizontal, and then you multiply that by the distance, and it gives you the horizontal distance. So you would walk up the hill, you'd have a pole at the same height as you're observing, up the top of the hill. You sight the top of that pole, and that's the inclination. And then you can work out by trigonometry what the horizontal distance, and that can be your measurement that you're going to draw on your plan from point A to point B. And obviously, if you're up a hill and you're measuring left and right, you're not going up the hill, you're going left and right of it. Slope distance correction is probably not going to be much of an impact. You probably not need to bother with it. But again, if you're in London, you're doing lots of stuff around London, it's going to be the things you're going to come up against are walls, fences, hedges, or whatever. And you can use a ranging pole or a big stick with a spirit level on it, make sure it's upright, and then you can get somebody else to help you with the same at the other end and try and get the levels the same. So you get horizontal distance. Does that make sense to everybody? Yeah. So a recap of these survey principles is the methodology that you're going to use, working from the outside to the inside. You need to be aware of the accuracy, the measurement accuracy, which we've just talked about. How do you measure things correctly? And you'll get better at that as you go along. But the accuracy then depends on the plot scale, and that is relative to sheet size, because you want to make use of your space. And then consistency. You know, don't chop and change. If you're going to use meters, don't use feet and inches. If you're going to use millimeters on your drawing, which lots of architects use millimeters. A lot of people end up with just using centimeters. So it's plus or minus 5 mil. But when I've picked up things, I've struggled because I think it's millimeters. So where it says 61, I think 61 mil, but it's not, it's 61 centimeters. So it's that as opposed to that. And then I did a half house. I set out a half house for a chap, a client. So this is a German kit-built house, and it was one of the biggest ones in the country at the time. And on the engineering drawings, when I went to a site meeting before we set it out, the client wanted me to make sure that I understood what he wanted. And I said, what's the small figure at the end? So they'd written the figure and then a little small figure at the bottom. And I said, what's that? And he says, that's the decimal for millimeters. And I thought, decimal millimeters? It's a bit tight, isn't it? I says, well, what's the tolerance? You know, what type of resolution? What's the definition? What am I looking at? Because obviously I'm using equipment, I'm doing survey methods, banging in pegs, measuring from, you know, in a house, as long as you get the walls all straight, the bricky is going to come in and brick or it's going to be a timber house. So this half house is they bring it in, slap it on the ground. He says, we don't have a tolerance. I says, what do you mean? He says, what you see is what you get. I says, well, no, you've got to have some tolerance. I've got to work to something. Otherwise I'm going to spend all my day just measuring that point a million times and spending a million times measuring that point, then a million times getting that. So it's a trilateration. He says, no, it's 0. So I thought, all right. And that was the same with the height. So this was a big house. So I went and set it out. And then because to put the concrete base down, you've got to have shuttering. So the chippies and the ground workers are setting up the shuttering. So I was coming along, set up my instrument, I roll it, bang it with my laser. Remember, the laser's 1 millimeter accuracy and 1 meter. I says, you're 2 mils out. Can you change that one? And that one there's 5 mils out. He went, what? I says, well, yeah. He says, what do you think we're building? A Swiss watch. I says, well, you might say that, mate, but it's almost like a Swiss watch. Anyway, I battered about because I didn't want to be held responsible for setting it out incorrectly. So where the shuttering was out with 5 or 10 mil, I got him to correct it. And again, you need to support your shuttering, because when you're pouring concrete, there's an amount of weight in the whole lot. And then you've got the pulling the pipes or you're pumping it or whatever's happening. But any shuttering is going to deflect because it's only built out of plywood just up against the wall. And we had to get it as best we can because with the construction methods that they were doing, I had no control over it. It was going to go all over the shop. But anyway, we got it done and I re-surveyed it and it was all right. And the chap phoned me at 10 o'clock on Saturday afternoon, Saturday evening. He said, David, this building, he says the German company's driving from Germany with the house on the back with 2 or 3 trucks. Monday morning, they'll be here at 6 o'clock and they're here for a week or 2, erect the house, then they go back to Germany. It's all booked and then they go to the next place. So him and his wife have set up a table in the concrete at 10 o'clock at night, having a glass of wine and a meal. And he says, I don't know if this is square. I said, what do you mean? He says, well, I'm sitting here with my wife out in the base. He says, and the walls don't look as if they're square. I says, Tim, you can't just look at something because it's going to go into infinity. The bigger and longer it is, it'll always look as if it's going. I says, and I started getting worried. And I said, it's got to be square because I checked and that was the big knees that was happening with the engineers that you got to move it a few mil. He says, all right. And I'm just thinking, flipping it. He says, can you get here first thing Monday morning? I says, yeah. Not to do it, just to oversee it. Well, anyway, I had a couple of meetings and didn't get there at 10 o'clock. And my heart was in my mouth, to say the least. And I hadn't any calls from him. But when I got there, they'd half the house up. So I don't know if you know what a half house is like, but they build the walls and then it's stepped in the bottom. So you get the windows, the electrics, the blinds, everything. And they were putting this up in the crane, put it on the edge, so it went in this step on the concrete. And they were wedging it in with big bars. And then they get that side on and bolt it together and work the way around, then they put the roof. And it was half out, half up. And I couldn't believe it. So I said, I think we're setting out, it's all right then. He said, well, yeah, it's fine, spot on. I thought, thank goodness for that. But then they forgot to put the hooks in to hook the centre of the roof. And they had to jam, make holes in the concrete as it was going off to put it in. But it's still up there, so it's obviously all right. But the accuracy was just unbelievable. And so for consistency, I had to make sure that my kit used was the same. Obviously, temperature affects everything, whether it be a steel tape or whether it be a bit of wood or whether it be an instrument. So your temperature and the moisture in the air affects either the infrared signal or the laser signal. And we're not talking about a lot, we're talking about tens of millimeters or hundreds of millimeters. But anyway, in this particular job, it might have had an effect. So when I said to him, can I have some control put in so that I can control the job, expecting him to put a little tape, a little peg in like this, right? He put me in meter cubes of concrete with a steel bar all the way through 3 meters down. So they were not going to go anywhere. And even if there was swell with the clay and things like that, they were there forever. So I said, that's wonderful. So I was centre punching these and then measuring between them. And I got it down to pretty jolly good as I did on Terminal 5, no, Terminal 4 it was at Heathrow. They asked me to do the major control on that, which I did. And then I get sent to Nigeria for 6 months. And I said, how did it go at control? He says, no, it's rubbish. I said, well, I did it 3 times. I had to do the control because the guy who was checking it for London Heathrow said it was wrong. So I said, oh, yeah, all right. So again, we had these computer cubes of concrete in the ground with a big brass plaque on it, and you would scribe up where the centre of your control survey was. So I was putting a little light scribe on it. And this was huge. You imagine Terminal 4 was quite a big area with the car park and the whole lot. And I did it 3 or 4 times, as I said, and each scribe mark that I did was only a flipping millimetre or something away from anywhere else. And what you do is you process it, then you correct it, and then you'd go back to site and get it exactly on. It transpired that the guy was checking the work. When he put his EDM on the instrument, if he didn't push it into click, it was reading 10, 20, 30 mil out every time he set the whole thing up. So he was saying, because he was a big wig in London Heathrow, saying, service crap, do it all again. Shite, as Andrew Wilson was saying. So I was in Nigeria and just went, because again, the company I worked for was huge, so they would have somebody else to do it. But it just shows you I was particular in what I was doing. And when I worked in the Thames barrier, we were doing the shift and latch for the big barriers that came up. And we were measuring that, and this was all with steel tape and, tape and offset. And every time I set up the instrument, I was pushed out of the way. And this guy from not Transport for London, but the London Authority would come up and check it was centered over the point, it was all leveled all right. And it was a bit off-putting because they're treating you as if you're an idiot. But I was a surveyor and I wanted to try and get it as best I could. So you see, it's fine. And when you're measuring your type, you say, right, that's 21.23. Push you out the way. Yeah, all right, I'll accept that. So it was very on your back, but you get used to it. And then it got to me thinking, I'm quite good. I can get the accuracy and I can get the consistency. And that's what I've done ever since. So where you want this wall surveyed, I will survey it. Whether you want it 50 mil accurate, 150 mil accurate, or 2 mil accurate, it'll be as good as what the instrument can give you. But I'll try my best to get it. So how do you commission a survey? Well, you want to brief the survey, as I say, and you want to have a discussion on it as well. You want to be having a chat saying, I'm not sure what plot scale I want, and I'm not sure the plot size, but it's only a little garden, so it probably fit, not in an A4. A4 is probably too small, so we'll go for A3. And I want it to make it sort of clear I can get it all. So you should have a discussion where they can advise you on what, and then advise you on, they should tell you what type of equipment you're going to use, and what the accuracy, and what the resolution, and what the definition is they're going to get you for it. So, and then what that's going to cost, and when they can start it, when they can finish it, or give you deliverables. And there's all guides within there, but basically it's a discussion. So you need to look at the site, recce the site, have an idea what you want. The client's willing to pay the money for a survey, get them in. But if it's only a little tiddly back garden survey, you're better off just taking loads of flipping measurements and have a go at it yourself. Because if you fail, it might only be because a couple of measurements are wrong. You know, I had a couple of students a few years ago that wanted me to go out and check their back garden. So they wanted to have a crack at after me telling them all this. They went out and tried to measure their garden and said, could I come out and check how good it was? So I went out with my instrument, my level, my drone, the whole flipping lot. The drone nearly took off because it was very windy and I sent it on me. And it was over a railway. But I got it back, managed to take a few photographs. And then I forgot to take my level staff. So I put everything in the car. And this is again the things with when you're loading up your vehicle, you're trying to think everything you need. And I forgot the level staff because I was too bothered worrying about something else. So what I had to do was tape a 3 meter tape to a stick, you know, like a broom handle, and use that, which was very cack-handed. But I was able to do the job. Now, she probably thought I was a complete idiot. But I checked her work, surveyed quite a lot of it, and she was actually very, very good. Because it was a long, narrow garden, there was only a couple of measurements at the end that were a bit iffy. Everything else was good. Everything else was fine. So it gave her confidence to move on. But I just felt a bit of a twit on one of the level staff. There you go. So a brief. Again, in the Dropbox, I'll show you a typical brief that we used to do at CD Service. And it probably seems a bit OTT. But if you go through it step by step, you can say not applicable or whatever. And it probably say in there about the grids. And if you remember, you've got a drawn grid and you've got a level grid. And then the other side, this side, is something that the TSA come through with, I think. And they were just talking about the different qualities of survey. You know, if you got a decent survey and you got a rubbish survey, what is the difference? And there's lots of stuff in there that'll help you find out what you need. And as I said, this plot scale can be, if it's down to what type of detail you want to do it. You know, if there's lots of features, there's going to be quite a lot of groundwork. So you're going to be digging out stuff, replacing stuff, bringing in slabs, soil, whatever. Is that, excuse me, there's a number of things you need to think about. And certainly one of them is the amount of levels you want and the accuracy of the points that you want to refer to. But again, once you've done a few of them, you'll learn how much information you really need. We're talking about that big trunk sewer going through it. How do you know if it's a trunk sewer? So if it's a manhole on your land, there'll be an easement, and you want to know if it's surface water or sewage. Well, on the list here, it's it's not 100%, but generally a trunk sewer, which is foul water, will be generally flowing all the time. Because somebody somewhere along the road will be flushing a toilet, emptying a bath, emptying a dishwater sink, or whatever. So if you pick up the manhole, you probably won't be doing it because again, health and safety cover. The surveyors will do it. But if they're unsure, you can have a wee look down it. And if it's flowing, then it's generally foul. The sides are usually benched up, and by that I mean that when they've got the pipe going through, it's half a pipe, and from the edges of the pipe up to the edges of the structure, the brickwork, they'll be benched, there'll be smooth concrete benched on. And then you can go into the house and empty the sink or flush a toilet, and you'll hear the water trickling down it, so you'll know that's the connection. And again, then you can keep away. You can find out where the depth of the manhole is, so it gives you an idea of how far you can dig down the ground. And likewise, in surface water, if it's not been raining for a lot, then it's probably not going to work at all. The thing is, up in London as well, a lot of them's what's known as combined sewers. Everybody know what combined is? Where the both of them go into the one. And this was the issue in the Thames, why they built that big, huge sewer down underneath the Thames all the way down, is because a lot of the properties are combined. So when it rains, it goes into the foul system and washes everything into the Thames. And it's not good. So they can't redo all the drainage in the houses or in the roads because it'd be a huge, imagine digging up the whole of London to put 2 sewers in as opposed to 1. So it's just never going to happen. So the only way they could get around it was get all the effluent, get all the stormwater drains to go into this massive big chamber, goes round the end of the Thames, and then treat it at the other end. At least you avoid it going into the water, the Thames water on its own. So drainage again is a thing you can actually start getting. We lifted about 10,000 manholes. I can't even remember. It was up in Nottinghamshire, and a Ministry of Defence site. It was empty. And we were up there for 6 months. So I was lifting manholes every day, 6 months, and trying to get connection. Where did we go to? Level. And there was one, we went down and borrowed a standpipe from the fire brigade and a hose pipe because we didn't know where this one was going. So we connected it the fire hydrant, hose pipe into the manhole. Friday night we went away. We came back the Monday morning. It was still pouring out water, and we still hadn't a clue where it was going. And there was some of them where you could drive a bus down. They were huge. So drainage is quite interesting. But if you've got any close to your site or going across your site, find out about it because it could catch you out. How do we check the plan? This is what I was going on about. The grid crosses. This is the grid that surveyors might ask you about. What grid interval do you want? And this is probably 10-metre intervals, right? 10 metres from there to there, 10 metres from there to there. The Ordnance Survey are probably 20-metre intervals there, or 50, or maybe 50. So that is your grid interval. And then the level grid is probably only about 2 or 3 metres. So I've gridded loads of them because it's a flat area. You can tell by the contours there's not a lot happening. And it moves up from there to there by, 58157. It's moving up 250, 300 mil. All right, so it's not big, but it looks as if it's steep. But that's because I've asked for 550 mil contours. All right. So that is how you can look at that. You can say, well, the writing's gone uphill, so that's rising up to there. Then you can quickly find out where does this go? No, that's rising up to there. So immediately the contours are a guide. If you've got a survey, an inherited survey, you can tell what it's doing. But it's also useful for, I've even contoured the hard surfaces. So that's the tarmac in front of Cambridge Cottage, which you don't normally do. A survey company would probably rip them out, or they used to do in the old days, because hard surfaces should be defined by the levels on it, and it's going to be pretty flat between one level to the next level. But I thought I'd contour it all anyway. So it looks a bit wiggly across there because the modelling software is looking at the levels on the grass, then the levels at the edge of the concrete or tarmac, and then the levels that I've taken round the edges. And remember, some of them are threshold, some of them are in flower bed. So the model is looking at that to create these contours. And ideally, you would say, well, the flower bed is in the ground. That shouldn't have an effect on the contour. And likewise, a step shouldn't have an effect on the contour. So you could manipulate this. So where there's a whole bunch of triangles around here, I could manipulate them so that that contour level comes straighter and it doesn't kick up. But that requires, again, a bit of work, a bit of knowledge, a bit of understanding the site. So the way around that is the surveyor would put a break line around there, and these are all break lines, which means that the contour triangle size, how it forms its digital terrain model, just a sense of triangles. I don't know if you've ever seen any of these facial recognition systems where you see somebody's mugshot and then you get all the triangles all forming over it. Same idea as it happens. So they force it that the triangle bases are all around the break lines. Then the contour has got no way but to go nice and straight across there. So I have manipulated bits of this that I think are reasonable to give a representation of the ground. So how would you check it? Well, you should have a scale bar when you're drawing. Every drawing that you produce should have a scale bar. Because whoever you give it to, if they photograph it or do anything, what they want to check the accuracy is correct to what you're saying on it with the plot scale. You then can check the detail. So you're walking about the site, make sure that's a control point in yellow, and then you've got covers in blue, and you've got green as the levels. Then you get red as the buildings, orange as the walls. This is what you're asking, how do you read it? And then, as I said, the grey, the contour lines. The fat ones should be a heavier colour, and it's not totally represented, although there is a difference between these ones. The one in the middle is a bit lighter. So ideally, you want to accentuate your major contours, and they can either be either the fourth contour or the fifth contour. But that's the survey company would do that, and then they would describe whatever colours they want on it. And then from that, you can check the levels of the contours. You know, is there a little slope up there? Is it fairly flat around there? You know, if you look at the garden, you go in there and it's all up and down, you think, man, but that contour's rubbish. It doesn't relate to that. So quite quickly, you can establish whether this is a good survey or a bad survey. And as I say, you can stand on there, you can look through the corner of that building, and then produce that onto the wall or to something else. And if you've got somebody with you, get them to hold a pole or whatever. And then from that point, you can measure bits of detail. And when you get the drawing, put a straight edge through there, and you can find it all links up. So all, if it's all good. You know, is the hedge about in the right place, at the right height, at the right width? And stand at the end of there, that wall all look right? You know, because it's probably intended to be built right, and you just want to shoot at the buttresses in the right places. There's lots of things you can quickly go over, which will give you a feel. A question.
Yes, sorry. What are the units of measurement there? I'm sorry, I can't read that.
What the units of measurement?
Times.
What these? What these?
Both the scale and the units that you're using to measure.
Right, the scale is 1 to 100 scale.
Okay.
And that's a metre interval, then 2 metres, 3 metres, 4 metres, 5 metres, 6 metres to 10 metres. And you can take that and measure between there and there, is it 10 metres? Is that what you're asking? The levels are related to the GPS height that I took, which is, sorry, yeah. So that's 5.3 metres above sea level at Newlands, related to the GPS that I took, all right? So I didn't have a benchmark, I didn't use a benchmark, so I used the GPS there. If I found that benchmark, well, I did find a benchmark across the road in St Anne's Church, and I've got a value for that of the Ordnance Survey. If I measured from here to St Anne's Church and then used the value that the Ordnance Survey gave me, it would be wrong. And then you ask the reason, why is it wrong? Because it's in a different position. They haven't got it where I've photographed it. It's somewhere else that I couldn't find. So it'd be unusual, and I haven't done it. If I levelled from here to there and it was correct, I just give up, I think, because it shouldn't be. It should be wrong. All right. So all these levels are related to the GPS, which is that geoid, which is related to Newland. So it's a mean sea level. And then I've just put text on it. DPC is 5.48. You understand what DPC is? Damp proof course. And so that's the black line that you'll get round the edge of a building. It's generally a bit floor level. They could be used as slate. They could be used as PVC, or I don't know, they probably come up with other materials. And the reason you notice is the joint, the difference between the brickwork is usually larger because they've got a bed. They put the DPC on it, and then they put another bed before they put the next bricks on. So you're going to get it a bit fat. And there's a plinth down this side that's broken off. So if you've not got a DPC, it's generally at the top of the plinth, at the top of the DPC, the plinth. Because what the idea is, they didn't want any water to seep in underneath or above it. So any rainwater come in would run off the top of the plinth and not out. So it's broken off, but if you look at where it's broken off, it's almost the same as the floor level, and it's more or less the same within 10 mil of the damp-proof course that they put on that when it was built. All right, and that can be useful level datum as well. So you can either use the floor level in there if you can get access to it, or you can use the DPC, which should be the same around the house until it changes direction. But the trouble is, if we're going to design all this and then to put hoarding up around the house, you can't use your datum level, which is not a good thing then. So if you have based it on your floor level of DPC, you want to then use it on a manhole or an IC, or certainly 2 or 3 other places that you can give it, which is a temporary benchmark, which you can use if that's got hoarding over it and you want to do more leveling, you can't use it from your base point, you can use some other datums that you've placed. So it's a good idea. Contours, how to visualize them. Well, you said you understood contours, and that's what it looks like. That's it on the ground. That's it. If you take big slices through it, and they're always red going up here. All right. Bulking. Anybody know about bulking? Bulking is what happens when you take stuff out of the ground. All right. So if you've got a site that's gravel and wet with clay, which a lot of London is, it's ballast underneath in clay, and where I live, there's about 200 mil of topsoil, and then there's about, I don't know, 100, 200 mil of clay, and then I've got ballast and sand to wherever. So when you dig that out of the ground, it expands 50 or 60%. So when you say to the client, oh, we've got 10 meters of soil to take out because I've worked it out with my levels. So we're going to take out 10 cubic meters. Great. So you phone up a haulage company. So you get 10 meters of material to come out. How much are you going to charge me? £500 a truckload. All right, fine. When they take it out, the truck only takes 10 tons, say, right? Which is 10 cubic meters. But you've got another 60%, so you nearly get 1.5. They need 1.5 trucks. So you got a second truck in, which is another 500 quid. And you didn't expect it. So bulking can have an effect off your material taken away. When you bring the material in, the same applies. You've got gravel, 20, 30%. So you bring in your gravel, you might use a compressor to pull it down to the height that you wanted. You've got to think about that, because once you compress it all down, you might need to order more than what you really need. All right? Yeah. So you say, I want 10 cubic meters of gravel, please. They give you 10 meters of cubic meters. You compress it down. It reduces by 20 or 30%. It's lower than what you need. You need to order some more in to compress that down, because it's bulked up before it came to site. Make sense? Maybe. Some scratching of the head there. Trust me, I must. Yeah.
What What makes the difference there? Is it just the
Air, is the
air?
air between it. So, and somebody asked me, would it be different if you used a bigger bucket or a little bucket? And there's a bit of sense in that. If you've got a little bucket, you're going to create more air pockets than you would do a big lump that's all compacted together when it goes in. But it's not an exact science. You know, you're going to get stitched up with it. But as long as you're aware that when virgin ground is getting taken out, it will expand. And if you're then asking somebody to remove it, it's not what you calculated. It's what this increase is that you need to think about how many trucks to bring in or take away. Yeah? Another question?
Like, who would do the calculation? You as the designer or orderer of material, like with the person who's not selling it?
Well,
Quoting the truck.
well, you as the designer would know what you're going to do with it all. But you might bring a ground worker in, right? So you've asked whose responsibility it is. You've done your design. You say, I need to remove, because there's calculations that you can do, 10 cubic meters of material. That's what you've stated. So you tell the ground worker, I've got 10 cubic meters of material. He might come along with one truck, take it away and say, oh, there's a lot more there. I need a second truck. So you don't want to say, well, I did tell you that. And then he says, yeah, but it's all down to bulking. I priced you for one truck, not knowing. So you want to make it clear that A, you understand bulking. And you say, I've got 10 cubic meters of soil or clay that I need to get out, gravel, whatever it is. Remember, this is going to bulk up. So you need to give me a price for taking that away and not coming wanting more money for more trucks.
Back and text every day and just do a job. Think about all.
Well, he would do, but if he's got an opportunity to do you out another 500 quid, he's going to. Definitely. You know, so this is the awareness with right of light, with boundaries, with bulk, and the whole lot of it. Actors as a service. If you've got the knowledge, you've got some power.
Yeah.
But don't talk, don't give too much away, because they might think, oh, she's clever. She knows it all. And then they say something else and think, what's a lot about it? Don't understand that. Then he says, I got you. I can charge another couple hundred quid. Yeah, it's an awareness. All right.
Is that the expansion and or the reduction?
Bulking amount means make it bigger. Bulk. Yeah.
The rocket bulk stands more than that.
Well, because there's bigger spaces between it. You know, if you've got a couple of big, funny old rocks, and you've got a cubic meter of them, there's probably going to be enough space between them all. That's what I come up with. I haven't checked it all. This is what got the internet. Don't hold me to it. But yeah, but I know that, because I've been there with the bulking, we're getting rid of material, bringing material in. Right, volume and area calculations. So we read on to it. How do you form all that? We split it all into triangles, circles, squares, rectangles, or whatever. And then you try and work out what your volumes are going to be. And that's from your levels, from your cross sections, from your long sections, or whatever you're doing. And then you can establish how much you need. And then you establish how much you need. And again, you can't just buy 10 cubic meters to replace it, because it's not going to be 10 cubic meters. You need to ask for 12 or 13 cubic meters, right? Because you're taking that material that's got holes and spaces in it to compress it down for your final design. Because that's what your design was based on. Well, your design was based on 10 cubic meters finished article. Well, that finished article needs a lot of work on it for 30 or 40 years of life for it to naturally compress. So when you're ordering your 10 cubic meters of topsoil, you need to ask for 12, 13 cubic meters. Yeah? Because it's going to compress. Because they'll give you the bulk. You ask for 10 cubic meters, they'll give you 10 cubic meters, but it'll be bulk 10 cubic meters. It won't be compressed. Nice block of 10 cubic meters. Effects of volumes calculated. All right. Where you get them is in your handouts. I think that's actually revision 9 now. It's not revision 8. But there might have only been minor spelling or something I've done. But basically, the list of handouts, you'll find it in there. It's LBC 22, section 22, number 1, 2, whatever it is, number 7. But in there's the description with the formula, how to calculate it all. Okay? And I have done, as I said, videos and things. And what I've done in the past is I've taken videos of the field work outside and the questions that people ask and the discussions, and then edited that, transcribed that, and shoved it onto my YouTube channel. And Marco's going to do this one today, which would be quite nice. I'm interested to see how it comes out. So he'll put that back onto the Dropbox or Vimto or whatever. What's it called? Not Vimto, that's a drink. And then you can all look at it. Now, whether you want it transcribed, I don't know. Because again, some people like to look at it, some people like to see it, some people like to listen, some people like to read. 9 on there and 8 on the other one. That's not very good, is it? Yeah, okay. So I need to update that. So this is it all here. So your area calculations and basic volume calculations are down in sections 21, 22. All right. But there's a lot of useful information in there. As I say, if you want to do your own survey of a back garden London property, if you went through this, you wouldn't go far wrong. All right. And if there's any problems with it at all, send me a text and I'll try and give you as much help as I can. All right. So you ought to ensure always your design you have a north point, because you've got to be looking at where the sun's coming in and going anyway, and it's going to affect all your plants that you put in. You always want a legend, because I had people find out what's a RG and what's a LP and what's a RTW. So a legend is showing you one up. There should be one in the corner there. Shows you what the abbreviations are, because you won't have enough room to write all the full text description. So you want to build a legend based on the sort of conventions, but certainly for something for yourself. You must contain a plot scale, telling it what it is, the scale bar, which is useful, because when you get to the design and then you want to set it all out, if you give it to a contractor and say, there you are, mate, that's my design, sort it out, tell me when it's done, he needs to have enough information for him to do it. And on that, you could have your 10 cubic meters. You'd say there's 10 cubic meters of soil that needs to be taken out here. Taken away, and I need 10 cubic meters of something else in there. So when he comes back with your prices and time frame doing that, you can make the question, have you accounted for bulking on that? You went, shit. All right. And if you want to see these surveys, contact them to give you a comparable fee, price or whatever. Either contact Andrew or Matt. And they should do it. And if you've got any issues at all, any questions once you've done it all, or you're actually out surveying or you're doing a job for them, give me a shout if there's anyone asked.
Completely your slide, north on the north, is that true north?
Grid, well, you get grid north, magnetic north, true north. So that is grid north, right? Which is more or less true north, because magnetic north moves about. It's all over the shop. Have you ever seen any traces over the last 10, 15 years? It's went to Alaska and comes back. And it changes about the core. It changes the position against the sun. There's a lot of it, but magnetic north changes all the time. So true north and grid north. And all the mapping that you'll come across will be basically on grid north, which is more or less true north. All right. Yeah, because if you cite Polaris as the North Star and try to do some calculations, hopefully you end up with north, who it is. All right. Yeah. Any questions? Anybody? Yeah, go on then.
Like true points to survey off.
Yeah.
They're just stay there forever, like those white pigs. Or once the project's done.
The question was, what's the control point? You can use anything. You could use the corner of that wall over there as a control point, and the other end of the building as a control point. but they're not, if you're going to do a lot of work and you want to come back in and refer to it, it's not ideal. Because you couldn't set up a survey instrument over that corner or the building corner very easily, because it's going to be in the way. So what I would advise you to do is, I can show you here, I've got a couple of nails in that I use for the levelling when we do it in the new year. Or a wooden peg driven in the ground, but obviously make it flush with the grass so that when the guy comes and cuts his grass, he's not getting any problems damaging his machine. But you want something that is going to stay there for the length of the survey, but also that you can come back to it in a month, a year's time, because somebody wants to extend it somewhere else, or bought next door. Can you now extend the survey next door? So you want to be, and you can buy 6-inch nails, you can get Hilti nails, you can get PK nails, you can get pipe nails. There's lots of different nails that will go into tarmac and concrete and bricks. And if you look, you start to look for these nails, and there was one coming up from a herbarium where I parked my car today, and there was 2 Hilti nails that far apart. And immediately my mind thought, why is that? Has somebody come along with some Hilti nails and banged another one in? So when the surveyor comes back to the next door, he doesn't know which one to use. It's 100 mil apart. The only way you could find out which one to use is do quite a lot of observations to see if it matches your plan. So, but Hilti nails and any type of masonry nail is useful to put in. As long as you can, it's going to stay there and you can measure from it and establish it. And if you got a survey company to come in and do it, that's what they're going to use. Unless they use a drone or laser scanning, because laser scanning can set up anywhere. And a drone, as you send it up out there, fly it. Again, for both of these things, they should have set up ground control. Because if you don't set up nails and ground control and measure between the 2 points accurately, it means their information doesn't relate to anything. Only relates to the GPS that the devices have got relative to satellites. And as I explained before, that can be anywhere. So they need to have ground control. So if you got a cheap price for doing a drone survey or a scanning survey, it seemed, well, you wouldn't know it's cheap, would you? But you could ask the question, what is your control based on? How are you doing the control? Because if they don't have a survey instrument, a total station theodolite to take a millimetre and a second of arc, and some good device to measure between there to there down to the millimetre, it's not ground control, it's not survey control, it's not survey quality. And by survey quality means whatever they're going to draw from that might not, you might never affect you. But if they're going high precision stuff, it would, because it wouldn't work. It needs to be proved. So somebody could come in here with a helicopter or a little drone, fly it all. But if he hasn't measured something that you can check it to, it's a waste of time. It might be good enough for you, what you want to do, but I would treat it very lightly. All right, so ground control is a must, because that's where you start. And that's where you put in pegs or nails at the start of the garden on the outside and work your way in. And as long as you measure to your boundaries from there across it, the triangles all over the place, you measure the boundaries, and then you come in and do your detail in the middle and in the building, the front and the face of the building. It should all work together, it should all be good.
Correctly, if you wanted to fly a drone to do your surveying, you'd need some ground, you'd need
Control.
points, measured points on the ground, so that when you've got your mapped data from your drone, you could then compare it, overlay it onto your real life measurements.
Yes.
How much measurement do you need on the ground?
Right, the
To
question.
make sure that you've got the accuracy.
Right, the question was a drone survey, how you need ground control. What is the, ideally, you would want the measurement to fix the mapping from the drone to at least as big as that or outside it. Because if you only do it a little bit in the middle, so you've got a drone survey that covers, I don't know, 2 acres, 5 acres, and you've measured 10 meters across 2 points, and we can measure that on the drone. Remember, photography lenses, the whole gambit is the whole lot, everything it destroys at the edges You know, it's good in the middle, 5–10% of a lens. Outside that, it gets distorted. Even though they're taking overlapped photography, 80%, 90% photography. So if you get 10%, the images over that 10% will be fine. What's the light outside? And again, we're looking at curvature of the Earth because it's all from satellite data. So if you haven't something that sufficiently covers what the drone is mapping, you're leaving yourself a little bit open. So you want at least, I would say 1/2 to 3/4 of it, but you want 3 points at least that you can actually measure. So measure that base, measure from there out to there, measure from there back to there. You know that's as good. And if you wanted a belt and braces approach, you could go halfway between here and here, make a point, and then measure from that point, which should be 90 degrees, across to your next point or whatever. And if that don't add up, it means something's wrong with them on the 3 dimension. Then you get it exactly right, and you say that triangle, and that triangle, and that triangle all work out. I know exactly where they are. When this mapping from the drone comes in, if it doesn't satisfy that, and whatever error it is, whatever percentage it is going to be exaggerated the further away you go. So whether it's wrong, it's 5% wrong between that measurement. When you go twice that, it's going to be 10% wrong. When you go twice to that again, it's going to be 30–40%. Yeah, okay. Any other?
Yeah, I'm just going back on slide with your contact. That was missing.
No problem. As I say, this is on PDFs. It'll be that is, I think it's already on your Dropbox. Anything else? Anything else? No, right. What we're going to do now is I've printed off some bits of here. Now, this is not ideal because the idea I got from Andrew Wilson was you guys need to know an understanding of the survey, but also how to check the survey when you get one, when you do one yourself. So because I had surveyed totally Cambridge Cottage myself and done it in a couple of methods, it was an ideal checking system because you could then find out that measurement is taken as wrong, slap me about. Because I don't know. I mean, there's obviously going to be errors because I'm only human, but we haven't found anything that's wrong. Well, we hadn't done in the past. So as we can't go there because it's getting used, we're going to do this here. And there's a couple of things in this that's quite useful for you, and I'll explain that. So we've got some sheets, all right? So that is the ordnance survey that was purchased by myself. And then I've got bits and pieces that go through here, showing you what I did with students, all right? And it means we're going over old ground effectively, but as I say, there's a couple of things in it that will be useful for you. As you know, as much as the bulking and the sheet size and the scale, there should be some things you'll remember. I think we did say something about that. So if we have a 5–10 minute break, Marco's meant to be here. I don't know if that was him coming in his bike. He's there. Hiya, Marco. We'll cut it there, and then if you each take a copy of the handouts, then I'll go out there and we'll try and see what that's all about. Okay, thank you all for your time.
Thank you very much. It was really interesting.
All right, thanks.
Do we need to take the measure or anything?
I'm not taking it, doesn't really bad. You don't find that.
Yeah.
Sorry.
Yeah. I don't understand how How does you know that was not the
Yeah, well, against the orange.
You.
What this used to go in to go down the benchmark. So you go from, as I said, the benchmarks are probably 200 meters apart. Right. So you got one benchmark level, and then to prove that, you come back. You can check that your readings are all right. What we used to do was then, if that compares fine, so to prove it, you go to a third one. When you go to a third one, if all three of them match up with the results, fine. So you could only use one, but you could go change. So that's the idea of bench. Once you take that bench out, you then level to the site. So in January, I'm going to show you how to do leveling. You relate the levels to the site, and then establish, as I said, 2 or 3 datum points, whether it be a gully or a map or a manhole or a corner of building style. Make sure there's stuff that might not get this. Once you get them, the levels and then related to the benchmark. Right. Anything you continue, you're not going to go back to the check. Somebody say,
Yes, I needed to hear that.